Introduction to Puppet. Puppet is a configuration management tool. You use it to keep the configuration of your machines, which are called nodes, consistent. There are several terms used in a Puppet installation, and we're going to cover those here, starting with nodes. Nodes are the machines that you wish to configure with Puppet. Facts. Facts are things that you can know about your nodes, and you access facts using the factor command. So if you're on a machine that has factor installed and you run factor by itself with no arguments, you'll see that it returns all of the facts that it knows about the system. You can also ask for a specific fact by going factor and then the name of the fact, and this is the IP address of my machine. I can also ask what interfaces does this machine have, or I could ask what operating system. There's also multi-level facts in more recent versions of Puppet, and what I mean by that is this fact OS is actually a hash that has several sub-items in it. I can also access something directly, like if I wanted to know what the major release was of this OS, I could type factor os.release.major, and I would get the 7 that I'm expecting to see there. Another term that comes up is master or Puppet master. And the Puppet master is the server that's in charge of configuring all your nodes. And that's basically your central server. This server runs a JRuby process called Puppet server in more recent versions of Puppet. In older versions, it was run as a passenger process through Apache or some other web server, but in more modern implementations, it's a Java process running a JRuby process called Puppet server. PuppetDB is another JRuby type process that is data warehouse of your installation. Most large installations will have PuppetDB be a separate machine from the master. And one PuppetDB machine can handle 5,000 nodes relatively easily. There are other techniques to go above that. Another machine in your installation will be a CA or certificate authority, or sometimes Puppet CA, a lot of people call it. And that's the machine that's in charge of your TLS encryption certificate. It acts as the certificate authority for your X509 certificate. All the communication between the nodes and the servers is done with TLS encryption. So this machine is in charge of signing the certificates and revoking certificates, deleting them for all the machines in your infrastructure. Now, Puppet is more than just a configuration management tool. It's actually a DSL, or domain-specific language. And that means that it has control structures and resources. So you can think of it like a language just like Python or Ruby. And indeed, the current version of Puppet is written in Ruby, but because it is a domain-specific language, it can actually be implemented in other languages. So in addition to the control structure, such as if, else, case, those sort of conditionals, there's also resources in the language, and the resources of Puppet are types. And types, which are listed on the Puppet's website, types are things like files, packages, services, things that you can know about your system, things that are easy to enumerate. Best way to get a handle on what types are is to go into an example. And we're going to create a manifest. And manifest is what Puppet source files are called. So the extension on these is .pp by default. And we'll create a hello.pp source file. So let's fire up our editor and create a file. So first thing we're going to say is we're going to create a file resource. We're going to call this resource hello. So this first line is the title of the resource. I'm going to put a colon at the end, signify the end of my title. And now I'm going to set an attribute. First attribute I'd like to set is where does the file live? And that's the path. I'm going to say it's in temp hello. Next, I'd like to say what the content of the file is. So I'm going to say that this is hello world. I'm going to use double quotes because I want to put a control carriage return at the end of the line. So I need that to be interpolated. And now I close my resource. So this brace and this brace match each other. And these arrows here, these assignment arrows, it's nice to have them line up. Not required, but it's useful. The other thing you want to make sure is that you have a comma at the end of every line to make sure that the syntax is correct of this resource. Without the comma, this would actually be a syntax error. So we can save that file. And then that file, if I want to apply that file to this machine, I'll need to use the puppet apply command. So what I'll do is I'll go puppet apply, and I'll give it the name of the file. And what that's going to do is compile this code into what Puppet calls a catalog. And the catalog is how Puppet organizes the resources that we've defined in our source file into a catalog or into a form that is able to be applied to the nodes. Now, if there was a problem, the catalog would not be compiled. So a lot of problems that people have when they first start out is that they might write code that's inconsistent or code that has syntax errors, and they won't get a catalog to compile. And without a compiled catalog, nothing will happen. This catalog did succeed. So we can see right here that it said it compiled it, and it created that file. And if we look at that file, we remembered that we put it in temp hello, and we can see that the contents of the file are what we expect. A big hurdle for people when they're first starting out in Puppet is metaparameters, and that's the next thing we're going to talk about. So metaparameters are extra parameters or extra attributes that you can add to a resource. The main four of these are before, require, notify, and subscribe. And we'll just look at before and require right now. Before, if you put it in one resource, it'll say that this resource has to come before the other resource. Require says this resource has to come after the other resource. It's that I require that other resource. And the best way to see this is with an example. So what we're going to do is we're going to create another manifest. I'm going to call this one order. And in here we'll create two resources. And what we want to say is we're going to have a file resource. We're going to put it in this temp order directory. I'm going to say that the content of this file is that I'm first. I've done a little shorthand here, and I've used the title as the path. Now I'm going to make a second resource. This time I'll set a title, but I'll make the path the directory that I want that other thing to be in. I'm going to say that this needs to be a directory. So now I want to say now I'm saying that I'm going to create this file in temp order, but then I need to make the directory. But I've specified the directory after the file. And let's see what happens when we say save this file and then apply it. Now we can see that what Puppet has done is it's actually created the directory first, and then it's made the file. And this is because in recent versions of Puppet, the auto-require mechanism has been enabled, where files will automatically require the directory they're in. Now, if we went back and we removed that directory and tried to make our file without the directory, this would fail to apply because the directory doesn't exist yet. We can also make the same failure happen by saying that this temp order, let's say that it requires, and now we're going to refer to the first file by capitalizing the resource type, which is file, and then using the title of it, which is temp order first. So now we're going to say that the directory requires that the file exists, which can't happen. So we're going to end up with another error that says the same thing, that I cannot create the file because the directory doesn't exist yet. And this is a big stumbling block when you're first starting with Puppet, is trying to figure out what this means. And although the auto-require mechanism does fix it for you, a lot of times that you can't rely on that. And the best way to do this is to actually take the require out and make it the correct way. So we want to make sure that we require the directory before the file. So now we're saying we want the directory, which is this one, order, to exist before we try to create the file. And now we'll see the results that we saw the first time, where the directory is created and then the file is created. And these types of ordering parameters become very useful when you have a very complex catalog. The auto-require mechanism can save you sometimes, but knowing how to use the ordering yourself makes things a lot easier down the road. Now, the next thing we want to talk about is modules. So what we're going to do is create a module. And a module is just a grouping of Puppet manifests. It's an easy way to refer to sections of code. And there's a hierarchical standard of the layout of a module. So let's make a new module, and we'll make this by hand. There is tools to do this with Puppet, but let's just make a directory, and we'll call this modules. And in this modules directory, we'll make a directory called example. We'll go in there, and then we'll make a manifest directory. And now we'll create the base class of this module. And by convention, this is in the init file. Because this directory is called example, we're going to be creating the example class in this file. So classes are defined with just the class keyword and then the name of the class. So this is going to be class example. I'm going to create another file. We'll call it hello. It's the same file we created before. And we'll set the content like we did hello. Now, we've got this class. Now let's create another class called goodbye. Now, because we called this file goodbye, Puppet will expect us to call this class example : goodbye. So this is the goodbye class within the example module. Create another resource in here. We'll call it goodbye. Make sure we get the quotes around it. And we'll set the content to so now we've got these two resources and we've got these two classes. So now if we want to apply this module, so if we're in this directory here, there we go. So we have the init file and the goodbye file. What we want to do is tell Puppet where to find this example module within the directory. So we're in this modules directory. So what we're going to do is tell Puppet that your module path is root mcli modules, and that I'd like you to execute the following command. And this is a new one, is we're going to say include. So we're going to say include the example class. And what this will do is create that temp hello file. We should probably remove that file, which we created earlier, though. We forgot to put apply. There we go. So we can see that Puppet was able to find the example class by looking in our module path, and it created the temp hello file. You'll note that it did not include the goodbye class. Now, what we could do is inside our init class, we can include the goodbye class right here by just saying include example goodbye. So if we do the same thing now, we should get the goodbye file being created. So now you can see that that file was created and the hello file was created. Now if we run Puppet again, you'll see that nothing changes. And that's one of the other big introductory features of Puppet, is that it is idempotent. It's idempotent, and idempotency, or when something is idempotent, it means that no matter how many times you do it, it ends up always the same. And the absolute value is usually the easiest example of another idempotent function. No matter how many times you apply the absolute value function, it's always the same. And that's the same with Puppet. Every time you run it, it should end up in the same state. So if we remove the temp hello file and we run Puppet again, it will create the temp hello file. But then when we run it the second time, it doesn't have to change the temp hello file because it's already there. The other thing is, if we came in and we changed the file and ran Puppet again, Puppet would revert the file back to its intended state. And this is what idempotency is all about.
In this video,
we're going to talk about some more code, Puppet code, and we're also going to get into Puppet server and environments. And the first thing we're going to talk about is in modules. How do we include files in our modules, just raw files? And what are templates, and how can we use templates to create files from our facts? So starting with files, let's go back into our modules example directory. And we've got the manifest directory. We've got to make two new directories. We're going to make one for files and another one for templates. I'll go into the files directory and we'll just create an example file. Say this is an example file. Much amaze. And we'll go back into the manifest directory and we'll create a new class. And in this class, example file, we're going to say that there's a resource, a file resource. We're going to call it source file. We have to make sure we set the path for this, and that's going to be in temp example file. We have to make sure the source is now set. And the source, we're going to use the syntax puppet : //. Now we can put a server here if we want, and another slash, but most of the time we leave the server name blank, and we just put 3 slashes, so that we get the file from the Puppet server that we're running the code from. So you'll see this quite often, the 3 slashes. It's very rare that people put a server name in there, but you can. And we'll say that we're going to get this from the modules example directory, and that we want the one called example file. And we close our class, close our resource. And now when we say Puppet apply, we'll tell it where the module path is, and that's the home directory, mPLI modules. And that we would like it to do an include of example : file. And what will happen is that this file will be created in temp example file. You can see there's the contents of our file. Now we can go into the templates directory and we'll do the same thing with a template this time. So let's make an example template. And we'll use the ERB suffix for this file, which is an embedded Ruby syntax. So this is an example template. Now, if you want to refer to fact in template, you reference them with an @ symbol. So @IP address, @hostname, @operating system. But you need to do that within a templating markup. So what we can do is, let's say we want to say that this node's hostname is, now we're going to use this templating markup to say, I want to print something in Ruby now. So I'll say @hostname. And as long as we have VI set up nicely, it'll colorize that for us. And we can also we can do looping as well. So let's say we want to talk about the interfaces. We can say, let's look at the interfaces fact. Let's split that up by a comma. And then for each one of the resulting items in the array, let's refer to each item as an interface. We're taking this interfaces fact, we're splitting it up into an array based on the comma, and then for each of those things, we're going to call each thing an interface. And then we're also going to put a minus sign here, and this minus sign basically says don't create a new line here. Now we're going to say the interface is, and now we'll do our syntax, and we'll say we want to just print the interface that we defined above. And we do want a new line here, so we'll leave the minus off. But now we have to close our loop. So this is we put the end in to close the loop. And that's the end of our template. So now what we can do is go back into our manifest directory and we'll create a template class. Again, we're going to create another file resource. And we're going to say that the content of this file is based on a template that lives in example module, and it's called example-template.erb. We have to specify where the file lives, so let's give it a path. And we need a comma at the end of that line. And we need to close up our file resource. So we've got our example template. We're going to do the same Puppet apply that we did before. We're going to set the module path equal to our home directory modules, -e include example template. You can see that that example template file has been created. And we can see that the fact, you can see that this interfaces fact, which contains these three interfaces, has been split up on the comma, and each one is put on a line by itself. We also can see that although I used the @ symbol up here, because I did it outside of the Ruby syntax, nothing happened. But I did use it here, and the host name, which is Puppet, has been returned, which is the same as the factor host name that we see above. And that's all we wanted to say about files and templates.
In this video,
we're going to talk about Puppet server and environments. So Puppet server is the server that's run Puppet for you and listens on the network. By default, the port that it listens on is 8140. And the way you install Puppet server is just to install the Puppet server RPM. So you would just do a yum install Puppet server. I've already done it on this machine, so that's already been installed. And then the other thing you have to do is just make sure that the Puppet server service is running. And you can see that that's running. And I can also verify that by just making sure that the 8140 port is being listened to. Now, by default, we had a modules directory that we were using. When we're using the Puppet server, we'll actually use a different location. We'll go to Etsy Puppet Labs code environments. And in this directory, that's where our environments will live. And the default environment for all nodes is production. So let's go to production, make a production directory. And in this production directory, this will be our first environment that we're going to run with the Puppet server. What we're going to say is, in this environment, let's create an environment.conf, and in there we'll say where to find modules. So we'll say you should look in this environment directory, in a directory called site, in another one called modules, and then you should go look in the base module path for modules. And we'll also specify where to find our site manifests. We'll say that it's in the manifests directory, and we'll call it site.pp. Now the site.pp file, let's create that first. We're in the production environment, so we're going to make that directory manifest. And then we're going to make a site.pp file. And in this site.pp file, we'll say that all nodes, that any default node will get a notify that says this is the production environment. So any node that we run in this environment should get that notify. So what we can do now, using just the production environment, which is the default, we can run the Puppet agent, and the agent is now the client version of Puppet, and we're going to connect to the Puppet server. And we'll do a test run, or -t. What that's going to do is connect to the local Puppet server and then run whatever's in the production environment. And in that production environment here, all there is a single notify. So you can see there is that notify. The power of environments is really that we can make more than that. So let's make a development environment. And the quickest way to do that, let's just cheat and copy our production environment and call it development. And we'll go into development. And we'll edit our site.pp and say that this is actually the development environment. And now when we do our Puppet agent, -t, we'll tell it to run in the development environment. And we can see that that notify has changed because we're in the develop environment. And although that's interesting, the real power comes from when we're in this development environment and we make a modules directory. And in the modules directory, we'll copy our MPLI example module that we created earlier, and we'll stick it in here. We'll have to do a -a to get the whole directory. So now we have that example module here. And what we can do is, let's put the same one in production. We'll do the same thing here. We're going to copy the example module here. Now, in our manifests directory, instead of the notify, let's also say that we want to include the example, and we'll do the same in our development. And now when we run Puppet, we'll run Puppet agent -t. This will run in the production environment, and we'll get everything that we are expecting to happen from the example module and the notify. The real utility of this mechanism is that I can go into this modules directory now of the development branch, And I can change things. So I can say, by default, I'd also like to include the example template file, and I'd like to have a notify that says this class this is the development class of example. So now we're saying, now we've made a modification to just the development environment. So we haven't touched the production environment. We're in the development environment. So now if we do a puppet agent -t environment development, we'll see that the Puppet server now runs against that different module. And we tried to include the example by class, but we didn't actually define it anywhere. So let's go look for example by. We're in this directory. Do we have the by? We called it example goodbye. Let's change it to example by. And let's run it again. And the idea being that I've introduced errors into this development environment, but production was unaffected. So production didn't have the error, whereas I can work through the development environment, find the problems, and then promote that code up to production. And that's really all environments are used for. It's just a way of separating your code out so that you're not changing everything everywhere every time you touch your code. And in the next section, we're going to talk about how to automate all of that with Git and R10K. In this video, we're going to talk about Git, control repositories, and R10K. Git is a version control tool originally written for dealing with the Linux kernel source code, but fairly ubiquitous at this point. And a control repository is actually a Git repository that contains all the information we need for an environment on our Puppet server. What we're going to do here is we're going to create a bare repository, and we're going to clone it, and we're going to make some branches. And branches are how you deal with different development lines in a Git repository. You can have multiple branches in one repository, and each branch can be dealing with a separate issue. And you can have, say, a production branch and a development branch. And the idea being that you work through all the issues on the development branch, and when they're ready or all the issues have been fixed, you migrate all that code up into your production branch. So let's start by creating a new control repository for ourselves. We're going to say git, and we're going to say we're going to init. Now we're going to use the special bare syntax so that we just have the Git control structures in the directory. We don't actually have any code in this directory. So we're going to say, we're going to put that in the srv Git repos directory, and we'll call it control.git. And that'll make an empty repository for ourselves. And next thing we want to do is clone that repository to a working location. So let's just git clone of that control repository. So now we're in the control repository. This would be the base of our Puppet server environment directory. And what we want in here is we want to have an environment.conf file like we made before. We want to have a module path. We want to say it should look in the site, the modules, and the base module path. And we want to say that the manifest is found in manifest site.pp. Now we can make the directory. Let's make the directory for manifest. And we'll create our site pp. And our site pp will be, again, a very simple site pp. We want to say that this is the master environment. And the reason for that is when you first create a Git repository, the default branch is called master. And we can verify that by going git branch. And it'll tell us which branch we're on. So now it's going to say we're on the the master branch, and we have these files, but we haven't committed them. So let's go up, and let's add the manifest directory, and we'll add the environment.conf file. Now when we do git status, we can see that these files have been added. Our next step would be to commit these to the repository. And Git's going to complain when we do this because we haven't actually given we haven't configured our Git yet. But we'll do that. We'll address that in a minute. So what we're going to do is we're going to say that we're going to commit these files to our Git repository. We'll have the message that this is our initial commit. And Git's going to complain up here and say that we should have set these things. And perhaps we should. For this example, you could set it to your own name, whatever. In this example, I'm not actually going to bother because this is a simple example. But what we can do now is we can push the changes that we just made into the Git repository. So let's push those. And we're gonna actually, let's list our remote. We should only have one remote, which is the origin, which is where I cloned this repo from. So I'm just going to push this into the origin, into the master branch. And now that's in the master branch. The idea is that this code is now living in that Git repository. So now if I go to the Etsy Puppet Labs code directory and look in environment, I have those two environments that I made earlier. What I want to do now is check out this control repository into a new branch. So what I'll do is I'll do a git clone of that control repository, and I'll call it master. Now I'll go into that master and I'll look at the code and I'll see that now we have in our manifest directory, we have this is the master environment. And if we do puppet agent -t -environment master, see that we get this is the master environment. Go back to our checked out version and let's make a new branch. So let's make a new branch, production. So we've made a new branch. Now we're going to check it out. So now we've switched to the branch production. Now any changes we make to this branch will not be seen in the master branch. Go to manifest and let's edit our site.pp. And let's change this to the production environment. So now we've modified our site.pp in the production environment. When we do a git status, we see that we've modified the file, so we have to add it to our commit, and we have to commit it. Again, we get the warning that we don't have an author name, but we're going to ignore that for now. And now we're just going to push this into the production branch of the origin. So now there's a new production branch of our control repository. We're going to go back to the code directory. We're going to remove the production directory that we created earlier, and we're going to do a git clone of srv git repos, control repos, and we're going to put that into production. We'll go into production, and we'll check out the production branch. Now when we cat the manifest site, we see that it's in the production environment. And if we run puppet agent -t -environment production, we'll see that the message that we get back has been changed to the production environment as we expected. And using this sort of technique, we could automate this a little bit, and we could have our repository checked out automatically with maybe some script. And we can keep our environment as branches in the control repository and have all of those work independently. And this became a very common way of using Puppet. And there were several scripts out there to do this. But one person at Puppet Labs, Adrian Thiebaud, decided that there should be a tool to do this, and he created one called R10K. So what we're going to do now is we're going to use R10K to do those steps that I just did automatically. So R10K you can install with a gem, or you can install with an RPM. I've installed it with the gem on this machine. So if I say which R10K, it's already been installed in user local bin, but if I look at my gem list, you can see that I've installed it with gem, and you would just install it with gem install R10K. But since it's already installed, there's no point in this. So when you run R10K, it tells you that what it can do is it can deploy environments, or it can work with Puppet files. And we'll talk about Puppet files after this, but the main thing that R10K can do is deploy environments. And it has a configuration file. So there's this configuration file called r10k.yaml, and I have an example r10k.yaml ready to go. And basically this is a YAML file, so it always starts with 3 dashes. And then in here you say, what are your sources? My first source I'm going to call control. And I'm going to say you can get the control repository from srv git repos control.git. Anything you find in this repository, I'd like you to stick it in Etsy Puppet Labs code environments. And I don't want you to prefix it. And what do we mean when we put a prefix on it? Basically, we'll create a copy of these lines to show what prefix would do. So let's say we want to have something like CTL. We can point to the same Git repository, but now we're going to say that the prefix is true. Now, what happens when I say, let's go to the Etsy Puppet Labs code environments directory. We have those 3 directories that we just made. We have in our control repository, we have a master and a production branch. What we're going to do is remove all of these. So now this directory is empty. And now we're going to say r10k deploy an environment. And I'm not going to specify which environment to deploy, so r10k will have to deploy all the environments. So what r10k is going to do is copy the contents from our Git repository into each of the branches. It'll make a directory for each branch. So we expect that we will see the master and the production directories in here with our master and our production code. Now, because when we created our example file here, we also made a CTL source, and we said prefix was true. What this will do is create a CTL underscore and then the branch for that repository. So we've got CTL master and CTL production. And this is useful if you have several control repositories that you wish to have synchronized into your environments directory. So again, we can now do puppet agent-t -- environment, and we can say CTL master, and that will print out the master that we were expecting. Same for production. Now, one of the other things that's really interesting about R10K is that it's based on an earlier tool known as Puppet Librarian. And Librarian invented this new file called a Puppet file. And a Puppet file was a way of specifying a set of modules that you wanted to have included in your environment. So if we go back to our control repo, we can see that we're on the production branch, and this is what our directory looks like. We'll create a Puppet file. And in our Puppet file, what we're going to do is we're going to talk about the forge, the Puppet forge. So the Puppet Forge is the public repository of modules. And what we're going to do is we're going to refer to some modules that are available out on the Forge. So let's say we want to get the Puppet Labs NTP module, and we'd like to get version 4.1.0. This is how we specify this in a Puppet file. You can also say, let's get the Puppet Labs standard lib, and I don't care which version, just give me the latest version. Now I can say R10K, and I can tell it, please check the syntax of my Puppet file. It says okay, I'll add it to my repository. And now I'm going to push this into my remote repository so that R10K can work with this. Now what we're going to do is we're going to say R10K deploy environment -p, which means read the Puppet file and do whatever the Puppet file says to do. And we'll tell it to do this in the CTL production environment. And this will take a few seconds because now R10K is going to have to go out to the Puppet Forge and download those modules and stick them into that directory. So now if we go to etc Puppet Labs, code, environments, CTL production, we'll see that there's now a modules directory that we didn't place there. That was put there by R10K. And in there, we expect to see two directories. We should see the NTP directory and the standard lib. And in here, this is the NTP module from the Forge. So now if I wanted to use this module, I would be able to reference it because our environment.conf says to look in the modules directory of this environment. The idea being that we could stick anything we wanted in there and reference it in our manifest. So let's go back to our control repository. And the other thing I should point out is that when we look in the production environment, it doesn't have the modules directory because I only deployed to that one. So if I wanted it to be in there, so you can see that this modules directory is now existing in this production environment as well, and it also has those two files in it. So let's go back to our control repository. And now what we'd like to do is create that site directory that we talked about up here in our module path. Let's make a directory site. And now we're going to copy that example module that we had before into this directory. And we'll do a -A to make sure we copy the whole thing. So now we have this example in our control repository. We can modify this, so we can say that this class includes this hello file, but it also includes a notify that says this is from the site directory. And now we need to close our class. Nearly missed that. And now Puppet, my editor was complaining about that. No, it's a good file. So now when we do our git status, we can see that these directories haven't been added. So what we want to do is git add the site directory. So now we can see that all of these example files are added into the repository. We'll make a commit. And now we'll go into the manifest and we'll say, can you also include the example file? Include the example module. So now we've got this one. We're going to commit that. And we're going to push this to our production branch. So that's been pushed to our production branch. Now, if we do an R10K deploy, environment-p of production, and we go to SC Puppet Labs code, environments, production, we'll see that the site directory is there now. So that now when I do a puppet agent -t -environment production, I'm going to get the contents of the example as well as the other modules. Now what I'm seeing right here is all of the plugins that were included in that standard lib module. So we can see that our example file got included and the update that this example came from the site directory. These things up here, these are all coming out of the standard lib module that we included.
Hello, and welcome to Mastering Puppet for Large Infrastructures by Packet Publishing. I'm Thomas Upbill. I am a longtime user of Puppet. I have been a system administrator for over 20 years, working primarily with Red Hat systems. I am also a Red Hat certified architect. And I also volunteer for the LOPSA board and my local LOPSA chapter, SASAG. You can have a look at my blog in the link provided.
Introduction to Puppet. Puppet is a configuration management tool. You use it to keep the configuration of your machines, which are called nodes, consistent.
All right, in this section, we're going to be creating a Puppet server machine from scratch, which we will call Puppet CA. In this section, we're talking about PuppetDB, and PuppetDB is what is used for exported resources. It's basically a data store for Puppet. You can use it to store your facts, your reports, and your exported resources. In this section, we're going to be looking at public modules. Those are modules that are maintained out in the public, and most of these modules are going to be found on the Forge. You may find them on GitHub or other places, but the Forge is a great place to start, and this is where all the modules are listed. In this section, we're going to be talking about Puppet reporting. And reporting in Puppet is handled by the node and the server. In this section, we're going to be talking about how to check the syntax of our code. And there's two tools we can use to do this. We can use Puppet lint, or we can use Puppet parser validate. In this section, we're going to be talking about Puppet best practices. And one of the main things that gets referred to as a best practice in Puppet is to adhere to the style guide. In this video, we're going to be creating a Puppet server machine from scratch, which we will call Puppet CA. And later on, we'll be building upon this configuration. But for now, we're just going to build a standalone Puppet CA with the IP address 192.168.50.100. And my test machine is going to be a CentOS 7 machine. So the first thing to do is install the repositories that Puppet maintains. Now, if you have a Debian-based system, there's an apt repository at apt.puppetlabs.com, and you would install from that. I have a CentOS machine, so I'll use the Yum repositories. If you had a RHEL machine, Scientific Linux, Springdale, any of those other ones, you would use this one. And the main thing to note here is that you can also install on Fedora, but these releases here, this release EL7 would be appropriate for our CentOS 7, but this actually installs the Puppet version 3. We want to install Puppet 4, and that's included in the release PC1. And this PC1 is sort of a new way of distributing Puppet, and they're going to be doing the all-in-one or AIO is sometimes abbreviated. So what we're going to do is copy this repository here. So let's just copy the address of that. Go back to our test machine and yum install that repository. Say yes to install it. And then we'll install Puppet server. This will include the dependency of Puppet, which is the Puppet agent RPM. And that Puppet agent is that all-in-one package that I was talking about. And that's why it's 23 megabytes. That's because it includes Ruby. So previously we used the systems Ruby, but now Puppet is including its own Ruby in the package so that there's no dependency issues there, because the version of Ruby that Puppet depends on is sometimes not available on the OS in question. The Puppet server RPM is 32 megabytes, and that's because it includes the Java that it needs to run as well. So all of the Java utilities are included in that package. So once this is installed, first thing we want to do is go into etc sysconfig and just edit the Puppet server configuration file that was created. And you'll see this Java args line right here. And what we want to do is come in and change this to 500 megabytes instead of 2 gigabytes. And that's just because I'm using a VM and I don't want to waste so much time waiting for 2 gigabytes of memory. And I also don't want to have my VM using so much memory when I'm only using it in a test environment. Now, if you had a machine with a lot of nodes that it was going to control, you might actually want to increase that to 4 or 8 gigabytes, depending on how many nodes you have. The next thing I want to do is just make sure that my hosts file defines this machine as puppet.example.com and Puppet, so that when I refer to Puppet, it goes to the local machine. And I can verify that by just doing ping and seeing that, yes, that's this machine. So the next thing we want to do then is generate a CA certificate. So we'll use Puppet cert list -a. And this will force Puppet to create a new certificate authority, or CA cert, for us. Alright, so now we've got a new CA. We can go to etc Puppet Labs, Puppet, SSL, CA, and we can see that that certificate was just generated for us. The next thing we want to do then is generate a certificate for this host. So we're going to do Puppet certificate generate. And we're going to specify some DNS alt names for this machine. We'll do puppet.dev.example.com, puppet.prod.example.com. If you had a bunch of other domains, you would put them in there. Then this is the name that the certificate we want attached to. So this is puppet.example.com. And we want to tell it where to find the CA. So we'll just say it's local. And that'll go and generate a certificate. So now that that certificate's there, we'll see that in the requests directory, there's this certificate request there. What we want to do now is sign it. So we'll do a puppet cert sign puppet.example.com. We have to say that we want to allow the DNS alt names. By default, they're denied. So if I didn't add this flag, it would have been denied. Now if I look in the signed directory, that's there, and the request has been removed. So the request is gone. Now, when we go to start Puppet server expects these certificates to be in one directory up in this certs directory, and there's nothing there right now. So what we want to do is go puppet certificate find puppet.example.com and just say that the CA is local. So now if we look in the certs directory, we'll see that that's there. We also want to find the CA certificate, so we'll just do that. And again, if we look up one directory, we'll see that those are there. And if we look in the private keys directory, we'll see that the Puppet private key is sitting there as well. So the next thing to do is then start Puppet server. And because this is a Java process and it's going to have to start up a JVM and then start JRuby inside that JVM, this can be a lengthy process. Typically on my VMs specifying 500 megabytes, I see this start within 10 to 15 seconds. If you have it set to say 4 gigabytes, depending on the speed of your VM, it can take 30 to 45 seconds. The trade-off is that once it's actually started, it's significantly faster than the previous releases of Puppet, where they were running through Passenger or some other system. Now, if all goes well, we should have this Puppet server listening on the Puppet master port, which is 8140. What I like to do is just verify that with LSOF once this is up. So now that it's up, let's just do LSOF. We'll say that we want to just verify that something's listening on the 8140 port, and there is. Great. Now, if we try to connect from our client machine, so we'll go over on a client machine and we'll do a Puppet agent-t. That should generate a new certificate for this machine. Then it should go and try and find a machine called Puppet, but we have a problem because the firewall or the system firewall on your machine may be in the way. So if we did an IP tables save, we can see that there's a bunch of IP tables rules, and this actually looks like a firewall D configuration. So what we want to do is add the Puppet server port to firewall D. So I'll just do that. We'll say 8140, that's the master port on TCP. And then if we want to make sure that this does the same thing when we restart, we'll make sure it's a permanent rule. All right, now that that's in there, Puppet client will now be able to talk to our Puppet CA. You can see that it generated a certificate for itself. So now if we go back to this machine and we say Puppet cert list, we'll see that there should be a waiting request. And the idea too would be that we would verify with this SHA-256 key that this is the right machine. So DEDDE7. And if I went over here, I would see that it's DEDDE7. And that's the SHA-256 fingerprint of that key. So now we'll sign that key. And now if we look in this signed directory, we now have 2 keys in that. So now we can do our Puppet agent again, and we'll see that it downloaded the certificate for us. There's nothing to do though because we haven't included any code, but we have a successful Puppet server. Now the code, the Puppet code that we want to run is in the etc Puppet Labs code directory now. And there's an environments directory. By default, the production environment is created for us. So what we can do is go into this manifests directory, and we'll just create a site pp, and we'll have it say something. And close the manifest. So now if we go back to this machine, we'll see that we'll get the notify. And there's our notify right there. So this is a perfectly functioning standalone Puppet server, and in the next section we'll build on that and make a load balancing configuration. In this video, we're going to expand upon our standalone Puppet CA machine, and we're going to create 2 Puppet master machines, and we're going to have the Puppet CA act as a load balancer for these 2 Puppet servers. They're going to be running on the Puppet Master 1 and Puppet Master 2 with these 2 IP addresses here. So what we'll do is we'll go back to our Puppet machine. This is our Puppet CA, and we're going to stop Puppet server. So we'll do system control stop Puppet server. And we're going to go into the Puppet server configuration file. And we're going to look at this webserver.conf, and what we're going to do is just take these 2 lines and make a non-SSL'd version available on a different port. So we'll use the port of 18,140. I basically just put a 1 in the front. And now what we'll do is also get rid of the 8140 because we're going to create a load balancer that's going to be listening on that port. So we don't want to have anything listening on 8140. And if you haven't done this already, the other thing to make sure of is that the Puppet server has been configured to not use very much memory, say 500 megabytes, which I've already done. The default here is 2 gigabytes. So we can restart. And while that's starting, again, that will take a few seconds to start, we're going to install mod SSL, which is going to bring in Apache for us. So here's Apache and mod SSL brought into this machine. So now, with that installed, what we're going to do is go to etc httpd conf.d. We're going to just verify. Alright, Puppet server still hasn't started, so it's still sitting there. Yep. And what we want to do is make a load balancer configuration. Now I've already made one, so what I'll do is I'll just copy it to this directory, but let's take a look at what this configuration file is. So I'm going to say that Apache is going to listen on the 8140 port, and I'll create a virtual host on 8140. Just make sure the machine knows that it's puppet.example.com. I'll turn on the SSL, and I'll load the certificates from the location that I know they exist because Puppet server was using them there. So there's the private key, there's the certificate. Here's where the CA is located. Here's where the CRL is located. And the other thing I'm going to do now is set up some headers to contain the SSL information. So I've got all the SSL information from the client being stuck into some headers. Then here's where the actual load balancing thing comes into play. I'm going to say, based on the URL that the client is requesting, if the client's URL starts with puppet-ca, I'm going to send it to a load balancer I call puppet-ca. Everything else I'm going to send to something called puppet worker. So I'll define the puppet-ca load balancer as just the local machine, this machine here, this puppet-ca, and the puppet worker is going to go to those 2 puppet master machines that we have yet to create. So with this in place, I have to go back to the Puppet Labs Puppet server conf.d directory, and I have to make a master.conf file. And in this master.conf file, I have to say that I want to allow headers, so the SSL to be available via headers. So I want to say master, and then I want to say allow header cert info true. And actually this method is soon to be deprecated, but this will still work. In future versions, this will probably be moved into the authorization configuration. But for now, we'll just do that. We'll just use this file. So this is master.conf. Now we're going to have to restart again. So let's do that again. And because I'm running in SE Linux enforcing mode, the next thing I have to do is set an SE Linux boolean. And this is just so that Apache can connect to the Puppet server processes running on the other machines. So now, with that configuration in place, what we're going to do now is go on to create a Puppet master machine. And I've already gone and created this machine. Now this machine has to have the same configuration. So if we go to etc Puppet Labs Puppet server conf.d, and we look at the master.conf, this one has to have the same setting as does this other Puppet server machine. And it's going to be listening on port 8140 as well, as we see there. And that's because we've modified the webserver.conf on this machine to do the same thing. It'll also be listening on port 8141, as we can see. So then, with those three things in place, and if Puppet Server is now listening, so this is if Puppet Server is listening on 8141, what we want to do now is start HTTPD. So we should use system control. So HTTPD is now running. Let's just double check that it's listening. Alright, so it's listening on 8140. So now if we went and ran Puppet against this local machine, so let's just look at our configuration. Let's make sure we don't have anything in here. So this is a stock file. Alright. So let's run against this machine. So now we're telling the CA to go and run, and instead of getting a message from the Puppet Master from this CA, because if we look at the Etsy Puppet Labs code, environments, production, manifest, site, if this was compiled against this machine, I should have gotten the notify about created on a standalone Puppet server. But actually what I got was compiled on Puppet Master 1, which if we go over to Puppet Master 1, you can see that that's what Puppet Master 1 said. And if I do the same thing, so I'll copy that. You'll see that it's Puppet Master 2. Now, because all we did for our balancer configuration, let's go back to that. If we come down here, all we did was just do a balancer. So what happens is every time we run, we just flip-flop between these two in a round-robin type configuration. So what we can do is we can just do Puppet Agent ST again, and because there's probably no one else talking to these machines, we're going to get Puppet Master 2. Next time, Puppet Master 1, Puppet Master 2. Now, what we can do is come in here and do stop the Puppet server running on this machine. Alright, so now if we come in here and do again, we'll see that our Apache load balancer is just going to send us over to Puppet Master 2 every time now because Puppet Master 1 is down. So in this configuration though, we should note that we've done all the SSL termination on Apache, so the communication between the CA and the Puppet Masters is non-SSL at this point, and we would want to make sure that the network that those machines are on is secure, or secure it in some other fashion. But by removing the SSL from that point, we can basically add as many Puppet Masters as we want to scale up to handle the load. And the CA, the main machine, only has to deal with certificate signing requests. So the load on the CA machine will actually be quite manageable for a very large number of nodes. In this video, we're going to talk about an enterprise configuration known as Master of Master, or MOM. And the idea here is that you will, in a large deployment, you'll need to be able to create a large number of Puppet Master machines relatively quickly whenever you have to address any concerns due to load, because each Puppet Master typically can handle 800 to 1,000 machines. So if you have 10,000 machines, you'll suddenly need 10 masters. The idea is that you make this manageable for yourself by creating a higher level of configuration, making it multi-level. So you can have a Puppet Master that you call the MOM that all your Puppet Masters go to. Your Puppet Master 1, the Puppet Master 2, and from there and there and there. The idea is that you would have this Puppet Master, the top level machine, the MOM, have a very basic configuration and not have it rely on any other machines, so that you can use this to just deploy other machines. The first thing you have to do though is modify the Puppet Master that we made in the last section. So what we're going to do is go to the Puppet Labs, Puppet Server, conf.d directory, and we're going to look at that webserver.conf, and we're just going to comment out the SSL port. the 8141. And with that in place, we will tell Puppet Server to restart. Now it's going to take about 40 seconds, so we'll just move on and move to our next section, which is modifying Apache. Now, we had this Puppet load balance configuration where if you were going to anything related to CA, you went to this local machine, but everything else went to the two workers. Now we want to have one where no matter where you want to go, you end up on this one, so that all of the communication goes to the CA. So I've created that configuration already, so let's just move that over. I've called it puppet.mom, puppet_mom.conf. So let's look at that. The only real difference in this file is the end here, where we're going to say that anything, this is the slash, anything will be sent to this puppet worker. And then this puppet worker is just a local machine on 8140. Now, hopefully nothing's listening yet. Let's just make sure. Okay, that's done. Good. So now let's do a restart of Apache. We'll use system control. Alright, now we should see Apache listening on 8141. Now, to get this working in my configuration, 8141 was not a port that was assigned to Puppet, so I had to add that to my SE Linux configuration, doing this command here, basically saying that the 8141 port is also a Puppet port. Without that in place, I would have run into an SE Linux AVC denial at this point, because I am actually running all of this in enforcing mode. Alright, with this in place, now what we want to do is go to our environments directory, and we would want to make a role or a profile, some module that's in charge of configuring our Puppet Master. So what I've done is I've made a Puppet Master role. It's very basic. It just makes sure that the Puppet server package is installed, the service is running. I would then put extra requires in here for all these other files, but this is really just a skeleton at this point. I would want to have our master configuration for Puppet server, which was this file here, to allow the SSL certificate info to be in headers. I'm using a Hiera doc as well here, so this is a Hiera doc configuration that says the contents of the file are these lines, and it's terminated by this word CONF in all caps, which is right here. And then the pipe character basically says that this is where the beginning of the text is. So if the file that's created here is basically going to have these three lines, with this being the first column in the file. So that's our Puppet Master role. The next thing we have to do is go in to the manifest directory, and we'll create a new site.pp that basically says if you're one of our Puppet Masters, Puppet Master 1 or Puppet Master 2, you're going to get this role Puppet Master. If you're not, you're just going to get a notify that says mom. And we can test this now on this machine locally by going puppet agent-t and then specifying the master port as 8141. And since Puppet server has restarted, we should just see the mom message, which we do right here. So now what we'll do is we'll go over to our Puppet Master machine, and actually we'll just make sure that that Puppet server conf.dmaster.conf file doesn't exist, and then we'll run puppet agent-t. Actually, before we do that, I believe I've already done this, but you would have to come in here and just make sure that the master port is set to 8141, which it is. So this is in our puppet.conf. So if we just do puppet agent-t here without any specifying the master port, because it's in the configuration file as 8141, it's now going to go to that mom machine, and it's going to use the Puppet Master role and it's going to recreate that file for me because that's in that role. Same thing if we went to Puppet Master 2. So let's just do that. Puppet Labs, Puppet Server, conf.d, master.conf, and run the Puppet agent-t. And we can see that that was recreated there. So in this type of configuration, all we would need to do is just add more masters to the system and put them in the site PP, or work out some other mechanism to make sure that the Puppet master role is assigned to our Puppet masters. And the idea too is that the CA doesn't rely on any of these other machines. These machines can be turned off, and the CA machine still continues to function. So basically you build up your infrastructure using Puppet. In this video, we're going to look at some of the performance tuning that you can do with Puppet Server. And one of the first things to look at is something we've looked at in previous sections, the etc sysconfig Puppet Server file. And in here, there's some arguments that you can set for the Java interpreter. And these first two settings are actually the initial memory size and the maximum memory size. And generally we set these to the same limit because we want it to use as much memory as possible, but we don't want to go over that. And I've set this to a low number, but in a production environment when you had many nodes, you'd probably set this to a minimum of 2 gigs and probably more likely 4 gigs. The other thing you can do here is any other Java arguments that you can use. And if you're having some problems with CPU spiking on occasion, you could use an option such as use G1GC, which would force the Java interpreter to use the newer garbage collector. And garbage collecting is just when Java goes through and cleans up its memory usage. The default garbage collector can be actually quite aggressive and use a lot of CPU. So many people have reported that using an alternate garbage collector helps keep their server running a little bit better. You can also print some of the details about garbage collecting by just saying print garbage collection details, in which case these things will be written out to a log file. You'll have to specify the log file as well, but that's easy to do. You can just add this option and then say put this in the Puppet Labs, Puppet Server, and then say Java or garbage collection log or something like that. So these are the options that you can set there as far as performance tuning. Another thing you can do is set the number of workers. So that's in the etc Puppet Labs, Puppet Server, conf.d directory. The Puppet server.conf file. There's a few settings in here. The max active instances right here. So this is the number of JRuby instances that we're going to have running at any one time. And the default for this is actually calculated where it's the number of CPUs minus 1. If you have need for many more to be around, or you've discovered some problems where you're waiting a long time for a new JRuby to start, you can put more on here, and that'll make it a little bit more responsive. Another thing you can mess around with, not in here per se, but in your Puppet.conf, is a setting that actually has moved into environment.conf, but you could set the environment timeout, and you can set that per environment. But an environment timeout basically says how long before Puppet goes and rereads everything in your environment directory. Like how long does that data stay valid for? And every time it has to be reread, you get a penalty for that. So if you have a problem with load, it's better to have the environment timeout be unlimited. So you would just say equals unlimited, and then the environment would stay till the end of time. The other thing to do is, just in general, and we see here I only have the production environment, and some places will have 50 or 60 environments, which should be fine. But then if you start exploding your environments to multiple of hundreds of environments, you actually end up in another problem where the server's taking too long to load in that data, and it actually slows down the Puppet server to have that many environments. Another thing to worry about is how many classes you have overall, because the server has to keep track of the classes as well, and that eats up memory also. So if you can reduce the number of classes that you have, you can actually save a lot of memory there. And another thing you can do is just on your nodes, to see if there's any problems with execution, is to go into the opt Puppet Labs Puppet cache state directory, and in here there's a last run summary and a last run report. If you look at the last run summary, it actually gives you some time data right here of how long it took to do certain things. Now obviously I have a very small configuration, and it's only taking 0.22 seconds to do things, or to look up things in the file bucket it's taking a matter of microseconds or milliseconds to do that. 100 microseconds. But if you had something where like the file bucket was taking a multiple number of seconds, this would show up here, and then you could go and look for that. Same thing for if you had execs in here or anything else. Obviously I have a very simple catalog, so I don't really have much happening in here, but this is a good thing to come and look at. In this video, we talking about PuppetDB, and PuppetDB is what is used for exported resources. It's basically a data store for Puppet. You can use it to store your facts, your reports, and your exported resources. And exported resources we're going to cover in a later section, but to get started with it, we're going to configure a machine as our PuppetDB. We're going to use the Puppet CA that we configured previously, but we're going to build a new machine that will house our PuppetDB and our PostgreSQL database. PostgreSQL is basically the only database that is supported by PuppetDB at this point. Future versions may support other databases, but at this point Postgres is probably your best choice. The quickest way to get started with this is to actually use the Puppet Labs PuppetDB module, which you can download from the Forge. It takes care of the entire configuration of PostgreSQL and PuppetDB for you. The only real problem with that is that it does obscure the details of how everything works. So we're going to do it from scratch ourselves. So the first thing we want to do is bring up our database. So we're going to install PostgreSQL, but we're going to use a later release than is included with our operating system. So I believe our operating system has 9.2, and we're going to use 9.5. So what we want to do is come into the yum Postgres repository and then find CentOS and grab the latest of the 9.5 series. The 9.6 is still beta, and obviously the 9.2 is what's included with our OS. So we're going to do 9.5, and first thing we'll do is just install that RPM. And with that RPM, we're then going to install the server. So that's PostgreSQL 9.5-server. Say yes. That should download the requirements that we need to get this going. And once that's installed, we're going to have to create an initial database. So we'll just make sure that Postgres is in my path. I believe I already put it in my path earlier. Yeah, but this is where those utilities will be located in this directory here. So you just add that to your path. With that in my path, I'm going to initialize the database. I have a previous incarnation of the data sitting around, so let's just remove that. All right, so we got a new database up. Now we're going to start the server on 9.5. So that's now running, so we'll just do a status on that. So that's running. The port for Postgres is 5432, so let's just make sure something's listening there. Alright, so Postgres is listening. The next thing to do is become the Postgres user and create the PuppetDB user for Postgres. So we'll do that with sudo. We'll become this user, and now we want to use the create user command. And we're going to use the password of packet pub. And I entered it wrong. There we go. Alright, so that user is now created. Now we got to create the database. We'll tell it to use UTF-8 as the language. Alright, so the database is now created. Now the next thing is we've got to exit out of the Postgres user. Let's get back into root. And let's go to var lib pgsql 9.5. And in the data directory, so this was just created by what we just did, we want to look at the pghba file, and we'll see that there's not a lot of content here for access to things. This is all by ident and whatnot. What we want to use actually is the password that we just created. So we're just going to add these 3 lines. Had these ready to go earlier. So this is basically saying that the user access to the database PuppetDB by the user PuppetDB is by an MD5 password from the localhost or from the IPv6 localhost. Now with that change in place, we now need to restart Postgres because we've changed the access rules. So we'll do a system control restart Postgres SQL -9.5, and while we wait for that, the next thing we want to do is come back and do a pSQL. We're going to connect to the localhost, we're going to connect to the database PuppetDB, and we want to be the PuppetDB user. And we just want to see, now it's going to ask for that password, and I said it was packet pub, and we're in. And there should be nothing in here right now. There's no database. So now that the database is there, the next thing to do is install PuppetDB. So let's just yum install that. So PuppetDB will be installed on this machine. Cool. Alright, so PuppetDB is now installed. The next thing we want to do is just run Puppet on here. And because I have Puppet running on a different port, I'm just going to get it to generate a new key for us. We'll get Puppet to generate a new key for us. So here's Puppet generating a new key. And then we'll go back to our Puppet server. Here. We should have PuppetDB waiting to be signed. PuppetDB should be signed at this point. Great. So now we just want to run it one more time. There shouldn't be actually much that has to be done right now. We're still trying to send PuppetDB facts, which we don't want to do yet. So that gives us the certificates. So the next thing we want to do is tell Puppet to use those, PuppetDB to use those. So we're going to do PuppetDB. I'm going to do an SSL setup command. And this is a shorthand command that will go and copy the SSL certificates into the right directories for us. So basically what it did was copy these over. It's telling me that because I've used this machine in the past and didn't wipe the old certificates, it's just letting me know that this is wrong. but it did copy the certificates over now for me. So if I go to the Etsy Puppet Labs PuppetDB directory, in the SSL directory, you can see that it's created these files for me. And the next thing to do is then go on to the Puppet server and tell it where to find PuppetDB. So if we're back on our Puppet server, we have to tell our Puppet server where to find PuppetDB. So let's go over to the Puppet directory. Now, we don't have a file yet, but what we do is we'll make one. I'm going to copy one that I had from before into here. And all this basically says is to go to the PuppetDB machine on port 8081. The next thing I want to do is copy the roots, the YAML file to here. And this is just a configuration file that allows us to use PuppetDB for, tells the Puppet server basically about where to find the node terminus. This file you really shouldn't have to play with very much. Now back on our PuppetDB machine, we're not quite done yet because we have to go in and tell PuppetDB where to find the database that we just configured. So let's go to the conf.d directory and let's look at the database.ini file, and we'll see that it isn't configured at this point, and we want to make sure that it's configured to use our Postgres SQL server that we created earlier. So all of these things have been commented out. So we want to make sure that the class name is the Postgres driver, the sub protocol is Postgres, the database address is this machine on port 5432 in the database called PuppetDB. The username we used was PuppetDB, and the password, which I said, was packetpub. So we've got the username, the password, the subname, and the protocol. That should be enough to get PuppetDB started. So what we'll do is we'll do system control. Tell PuppetDB to restart. While that's restarting, it might take a few seconds. While we're still in this directory, we do have to actually tell Puppet to use that store config backend. So what we'll do is we'll tell it that store configs is true and that the store config backend that we wish to use is PuppetDB. So with those two things in place, we should be able to start working again. We do have to wait for this to restart. Okay. Now we want to make sure that the 8081 port is listening. That is correct. And the 8080. Yes. So PuppetDB is listening on those two ports. We can verify this with system control status PuppetDB. So PuppetDB is running. It's sitting there waiting. We can try running our Puppet agent again. And Puppet should try to store its information in PuppetDB. Now PuppetDB is showing it has the wrong certificate, so we've obviously screwed up with our SSL setup. So let's go back to PuppetDB. These certificates are too old. Let's remove them. And do PuppetDB SSL setup. That's probably what that error was telling me before, but I wasn't listening to it. It created the directory out underneath me. Alright, those look a little more up to date. We do have to restart because the certificates changed. Out from underneath PuppetDB, it'll have to be reloaded. And once that's reloaded, we'll be able to run again and just see if we can connect, if our facts can be sent to PuppetDB. This time to restart can take a varying amount of time depending on how fast your VMs are. For me, it usually takes 15 to 20 seconds. Alright, let's verify that that's listening. Alright, let's just do the same Puppet agent run against our PuppetDB. Alright, so you can see that it now is able to submit our facts into PuppetDB. So now we can go back with psql, go to localhost, go PuppetDB as the PuppetDB user to the PuppetDB database, and we'll enter that password. And now we should see a bunch of relationships. So let's make an extended display. So if we look at all the entries into catalogs, we see that there's nothing there yet. Catalog resources. You can see there's nothing in there right now. We can quit. We will go and run Puppet again. So we got a good run on here. Puppet was told to run. And if we look back on our Puppet machine, let's just verify that. Alright, so we've got our Puppet machine is configured to use the store configs of PuppetDB. Store configs is set to true. So now what we're going to do is restart Puppet server to tell it to use that setting. And again, because this is a nice Java service, we're going to have to wait a little while this restarts. And once this restarts, we will have to run Puppet again on PuppetDB machine just to get a catalog into our PuppetDB, because the last time we ran it, we weren't actually storing we weren't using store configs yet. Alright, so that's been restarted. We're going to run one more time. This time, we should see that the information gets sent to PuppetDB. So let's do a psql. Do an X. We can see that this is the catalog from the machine that we just created. So this was sent in here. And now if we look at catalog resources as well, we should see that notify that we created earlier. So here's the entry for that notify that we saw. And then these are just records that are in every catalog. But this right here is the one that we created, the one that said created a standalone Puppet server. And if we scroll back, we can see that that is the message we got from our notify. So our PuppetDB is working. And that was not an exported resources, and what we'll cover in the next section is what exported resource actually means. But as we can see right here, that exported is false. So we'll cover that next. In this video, we're going to be talking about exported resources. And exported resources are just regular resources that have been marked as exported. They're not applied, but they're put in the database, PuppetDB, the store configs backend, with the exported flag set to true. So if we connect to the database and enter the password we created earlier, we select all the catalog resources where exported equals true. You see there are none at this point, so we'll have to create an exported resource. So what we'll do is we'll come into our site pp and we'll say for all the default nodes we're going to create an exported resource. This is the host exported resource, and we're going to use the host name of the machine as the title of this resource. Then we're going to use the Ethernet 1 IP address for the IP address, and we're going to create 3 host aliases. One, just the fully qualified domain name, another one, the hostname.packet, and another hostname.localdomain. We'll create a notify in here just so we can see that something's happening. And that's the end of our manifest for the default nodes. Now we'll create another one for our MPLI node, which is our client node, and it's going to be doing collecting. So this is the collector syntax. So we're going to say all resources of type host we'd like to collect. So this is the export and this is the collection. So what we'll do now is we'll just run Puppet on this machine. And what that's going to do is create an exported resource in the catalog, because we've said exported equals true. We can see that that's right here. And then it is a host resource. Now, this is the ID of the resource. So what we can do is we can say select star from resource params where the resource equals this ID. And we can see that this is a host. Here's the host aliases. There's the 3 of them. There's the IP address of the ETH1 interface. And these are 2 separate rows in this database. So those 2 things exist now. So now if we come back to our MPLI machine, and we see that the hosts file only has this 1 line in it, but if we run puppet agent-t on here, we're going to see that a new host entry will be created. The host name will be called Puppet. So now if we look, you can see that this entry before up here that just had these 2 names has now been expanded to include those other 2 names, the packet one and the local domain one. Now if we come back to our PuppetDB machine, and what we'll do is we'll just background that search, and we'll do a puppet agent-t on here. We'll see that we get that help notify to notice that we are in the default class. We'll go back into the database, and now we'll run the same query, select star from catalog resources where exported equals true. And we can see now that there are 2 resources, and that this second resource, which is the PuppetDB one, has this ID. Let's copy that one and look for that. So now we can see that there has been another 2 entries with puppetdb.example, puppetdb.packet, and puppetdb.localdomain. So now the collector should find both of these resources. So let's run Puppet again. And we can see that the PuppetDB machine was now added. So we see that that was added to the end. So now we have both of these. In this video, we are going to be looking at some of the PuppetDB GUIs that are out there. And these are GUIs that were developed by people in the community to show the data that's in PuppetDB. And we'll also look at the performance dashboard, which is something that's included with PuppetDB itself. And first thing we'll do is look at this performance dashboard. Now, to use the performance dashboard, we'll need to create a certificate for ourselves. So what you want to do is, on your machine that you're going to be browsing from, you're going to run Puppet Agent, and then you're going to tell it that the cert name is your name. You'll have to use lowercase here. Now we need to go back to our Puppet server, and we're going to have the certificate sign. Okay, so now the certificate's been signed. We'll run Puppet again. This time it'll download the certificates. So now we want to go to the .puppet directory, to the SSL directory. And what we want to do now is combine the certificates for our certificate, the TommySapPill one. And we're going to make a PKCS12 file out of this. So we're going to do OpenSSL PKCS12. We're going to make an export. We're going to start with the key. We're going to use their certificate. This will be the private key. And where is the CA? So we'll do the CA, and then we'll tell it what to put the certificate into, and we'll just call it TommySapPill.p12. It'll ask for a certificate. We'll just use packet. All right, and now with that certificate in place, what we want to do is come into the preferences of our browser. So we'll come into the preferences by just going here, preferences. This is Firefox. I'm going to go into the advanced view certificates. And now there's no certificates defined for me, but I'm going to import one. I'm going to tell it to go to the Puppet SSL directory. I'm going to click on the Thomas F. Hill P12. It'll ask for that password, which we just set. We'll say OK, and then it'll tell us if it was restored. Yay! All right, so there's our certificate. Looks good. Looks good. Now, if we want to go to PuppetDB to the dashboard right here, now we can go. Previously, it wouldn't let us in and would ask us for a certificate to get into this website. And this basically just shows us some information about the running Java process that is PuppetDB. And the longer it runs, the more information it will show you. When you first started out, it's quite normal to see a lot of question marks here because it hasn't really collected the data yet. Like I think there's a question mark there, and that's just normal. You'll see that until it's been running for a while. And I had this running previously for about an hour or two, so you can see there's a bit of data there, but not a lot right now. So that's the performance dashboard. The next one we want to look at is Puppet Board. And Puppet Board is right here. Puppet Board is easily installed using the Puppet Dashboard module. Again, all of these GUIs, unless you have a reason to, I would install them on the PuppetDB machine just for performance issues. So the Puppet Board, it's relatively simple to install with this module. You can embed it inside Apache. The easiest way to get it started is to actually start it from the command line. So if you come to your PuppetDB machine and you go into this srv Puppet Board directory, you'll see there's a dev.py. If you just run python dev.py and then tell it, it's going to listen on the default.
In this video, we're going to be talking about PuppetDB APIs. And to access the API, you'll either need to use a certificate when you're on a different machine, or if you're on the local machine, the PuppetDB machine, you can connect to the port 8080 and use it without SSL. But if you want to use it anywhere else, you'll need port 8081 and you'll need certificates. Now, we generated certificates previously by just running Puppet Agent. We're going to use those certificates now, and we'll just use them with curl. So here's how we can use it with curl with the certificates that I have in my .puppet SSL directory. So if we do a find in this directory, we'll see that I have this Thomas F. Hill certificate right here. So what I want to do is just try this query here. All right, and you can see that I didn't actually specify an endpoint, so nothing's happened. Now, the default endpoints are the environments, the resources, nodes, facts, and there's actually maybe another 4, but these are the main ones that are important. All of these are documented at this web page right here. But basically, if we wanted to look at all the environments, we would do the same thing, but we would put environments at the end. And this would return all the environments that our machine knows about. Now, obviously, I only have production here, but if you had more. Resources would be every single resource that's in the catalog, in PuppetDB. So you can see there'd be a lot of them. Obviously, I have to make it only resources. There you go, like that. So there'd be a bunch of them, and you can notice that it's returning a JSON. And the easiest way to view this is just to pipe the output through JQ. And you'll see that that'll make it a lot more readable. But as that is, you can still see there's a lot of information there. If you did all the nodes, if you had a lot of nodes, there'd be a lot here to look at, and the facts as well. There's also some
built-in paging mechanism where you can say, give me like 10 of these, and then you can do like paging offsets. And that's actually what a lot of these GUIs do, is just use this API and use the built-in paging mechanism. The other thing that's useful to do is some queries. And you can query on each of these endpoints with a special query. So the query language is, if we just look at a query, here's a query that I've done. I could say I can look for a resource of type file. So if I did this query on the nodes backend, but then I said data, URL encode, and then I said the query is going to come from this file called query, and this @ sign here is really the demarcation. And that would say, well, then I want everything that's of a type file. I'm going to put that into JQ, and then it's going to tell me what's good or bad about what I did. Oh, but I did it in nodes. I wanted to be in resources. It's nice that the error messages actually tell you. So I don't have any file resources in my PuppetDB right now. So let's go edit that query. And we know that we had some host entries because previously we had made all of these host entries, some exported resources of host entries. So if we come back here and we say we want the type to be host, and we do the same thing, we'll now see that there are some resources returned. There's host, there's the name of the host, there should be the aliases, and then the IP address should be in here as well. You can see this one has an IP address associated with it. This one does. So that's how easy it is to query. That's a simple query, obviously. That's just one thing. If you wanted to query with two things, you can say and then all of the things you want to and, or you can do an or. So if it was an or, you would have this or this. If I add another phrase in here, I'll get another and. So let's say we want to do type notify and the title is hello. So we'll come back here and we'll say that our type is query2. It says that it didn't find anything like that. So let's go back to our host example up here. You can see that there's a bunch of ones that were type host, and then there was one that the title was Burnaby. So let's look at that. Let's say that the type is host and the title is Burnaby. We could see that we only got anything that fit that description. So you can build up queries this way, and actually if you're using one of the GUIs, a lot of the GUIs will allow you to create your query in the GUI and then just export it, and then you could use it in this sort of arrangement. The GUIs are probably better in a lot of cases, but this is really useful if you're going to build your own backend or you're trying to use this to script with something else. That's the introduction to the PuppetDB API.
In this video, we're going to be looking at public modules. Those are modules that are maintained out in the public, and most of these modules are going to be found on the Forge. You may find them on GitHub or other places, but the Forge is a great place to start, and this is where all the modules are listed. There's two subcategories on the side. In addition to just random public modules, there's also a set of Puppet supported modules, and those ones are actually maintained by Puppet employees. And there's also Puppet approved, and Puppet approved ones are basically they've had some sort of standards applied to them and they're basically got an endorsement from Puppet. So if we come and we look at the Puppet supported, these are sorted by the number of downloads, and standard lib is always at the top of this list. So that's a really good one to start with. And many of the features that are in standard lib are now part of the core Puppet. We'll look at one of the ones that's quite useful in it to start with, but first we'll download it. Now, any of these modules that you find in the Forge, the first thing you want to look over here is at the project URL, and this will take you over to GitHub or wherever the project is hosted, and then you can go and look through the code yourself and see what you think of the code. I wouldn't just randomly download things without taking a look at the code first. But let's start by downloading that. So the first thing I want to do is I want to run puppet config print module path, and this is going to tell me where my modules are coming from. So now what I want to do is just make sure there's nothing in there right now. So I want to look in my .puppet code modules directory. There's nothing in there right now, so what I'm going to do is puppet module install puppet labs dash standard lib, and that is the same URL as I would find on the Forge. It's puppet labs, and then instead of a slash I just put a dash. So that installed the latest version of standard lib, and now if we go back and run our ls, we'll see that standard lib is in there now. And standard lib defines a few things, and one of them is file line. And file line is a way to add lines to a file. Let's make a standard lib.pp, and what we'll do is we'll create a file line resource. So the first thing we want to do is create that resource. So we'll just say file line. Now we got to give this a title, so we'll call it no root login. And now I'm going to tell file line that I wish to ensure that the following line is present in the file. And the line that I would like to be present in the file is permit root login no. So I'm basically disabling that feature. Now I want to make sure that I match any lines that might have something beginning with permit root login. So I'll start with an uppercase caret to do I'll start with a caret, and that just regular expression syntax for saying this line should start with this text. And then I'm going to say that it can have any number of spaces after it. I don't really need this, but might as well play with it. And now I'm going to say which file am I actually talking about. And since I'm running this as myself, I just made a backup of my sshd config in this directory. So with that resource applied, I'm going to now go puppet apply standard lib.pp, and what that's going to do is go and find that file and remove any instance where permit root login was yes. So let's take a look at that file. So here's permit root login no. Let's change that to yes and see what happens. And we can see that that line, if we go back, because VI will remember where we were, it's now been changed to no. So no matter what we change, now because we didn't specify, we can also come back and change it to anything other, even something that's invalid. It doesn't really matter. It's going to be changed to a no. So we look again, it's been changed to a no. Now the power of this utility is that I can come back and I can make another change to the same file. So I can say ensure, this time I'm going to say absent, and the syntax for absent is a little more complex, but we'll get through it. So what I want to do is I want to say that it's absent. I'm going to match, so I'm going to use the match parameter again, but now I'm going to say any line that begins with port. Now, even though I'm saying it's absent, I still have to specify what the line is, but now I want to say, I'm going to modify the same file. Now this is the interesting part. I'm going to say match for absence is true. So that's going to say it's still going to try and find a match even though it's looking to remove the line. The next thing I want to do is replace is false, because I'm not actually replacing the line, I'm just removing the line. And then close the resource. So let's go to this SSHD config file and say we find the port line. And we'll say that we'd like SSH running on port 8888. Well, when we do our apply, what this is going to do is remove that port line. So now when we go back, we can see that that line's been removed. And indeed, if we just grep for port, we see that it doesn't have that line in it. Now, another thing that's kind of useful is if I came in here and so let's say that there was 3 different lines that had 22, 22, 22, 80, maybe some ports that don't make any sense. When I come into my standard lib pp, I can actually add another parameter that says multiple. And this will say, if you find more than one match, I don't really care, just remove them all. So now, if I do my apply again, that's going to remove all of those lines. So now, we'll do the same grep. We'll see that all of those lines have been removed. And that's really the usefulness of this function, is that I can modify sections of the file using just this file line resource, and I could have these in different classes and they wouldn't interfere with each other. So that's file line. That's a pretty nice one. Another one that I wanted to show you was concat. So concat is also one of the supported modules here. It's fairly high in the list. So if you click on concat, now concat is a way to build files from fragments, and it's a little complex to begin with, but we'll go through an example and maybe it'll become a little clearer. So let's do that. Let's first install the module. Again, just using module install. So puppet module install puppet labs dash concat. And that's going to go and download the concat module, which depends on the standard lib module, but we already had that. So we're going to make a concat resource. First thing you want to do with a concat resource is you want to create the container. So we're going to create the container, and we're going to call it bash rc, because we're going to refer to this a few times. We just want to say where that is. We're going to say the path to this file is temp etc bash rc. Now we're going to specify our fragments, and these are basically the parts of the file. I'm going to make this a little easier to read. So what I'll do is I'll use a here doc, and we'll define a local here doc. So this is the contents of the string that I'm trying to define right now. Path equals path, and this is bash syntax. User local bin, user local s bin. So I'm just going to export that path. Now I want to make sure that the here doc's complete, so I'll just say that that's the end of the local. We'll make another here doc. We'll make this one for umask. Actually, we'll just do one at a time. So here's the local one. And we'll call this fragment local. We're going to say that the target, so this is the file that we're actually going to try to apply this to, is bash rc. That's this one up here. So we're referring to that one. The order, where is this going to be in the file? I'd like it at the beginning. And the content will now be that here doc that I defined earlier, so I'll just say local. Now, this is going to create a temp etc bash rc that has this contents in it. So if we do puppet apply concat.pp, it's going to go and create that temp bash rc, and if we cat that temp etc bash rc, we'll see that it only has that one line in it. Not very interesting, but it's a good thing to build on. So let's do another one. Let's come back. We'll make another here doc, and we'll call this one umask. And I'll say if the UID is greater than 500 and the ID-gn. I can really just copy this from some other source, but the idea is that I'm just going to put this in the file. Then, now we're going to set a UMask of 002, so that's the restrictive UMask. Otherwise, we're going to make it a nice open UMask. We'll say fee, and then we'll just mark the end of the here doc. So this is the contents that we want to have placed in the file. So now we're going to say we're going to create another fragment. We'll call this one UMask. We'll say that the target, again, is #rc. The order probably should be 2. And the content will be $UMask. Close the resource and apply. Alright, so now if we cat that file, you can see that what it did was it appended those 2 things to the file. So the idea is that I can build up files by creating multiple concat resources. Another thing that's kind of useful about concat is when I'm up at the top here and I'm defining the actual target, I can also add this warn equals true. And what that's going to do is put a header on the file as well. So if we run again, we'll see that a little header gets placed on the file. So there's that header right there. Alright, so the third one I wanted to show you guys was, let's go back to our Forge, and probably a little further down, but still on the main page, is INI file. An INI file is another way to manage sections of a file, specifically INI syntax files. So INI configuration files. These are really popular configuration files. And one of the files that's configured this way is our puppet.conf. So first off, let's just remove our puppet.conf. First thing, puppet module install puppet lab /ini file. Oop, that's inin file, that's cute. INI file. And you notice that I can use the / or the - syntax. The module install command doesn't really care. So that's been installed. Now let's make a ini file.pp. And what we're going to do is we're going to play with that puppet configuration file. The ini file module creates 2 resource types. There's an ini setting and an ini subsetting. So we're going to start with an ini setting. And the first thing we're going to do is create one that points to our Puppet server. So we'll call it Puppet server. First thing we want to say is which section of the configuration file are we going to be dealing with? We'll be dealing with the main section. The path to this configuration file is my home directory .puppet.conf. The setting that I wish to change is the server setting, and the value that I want to set is puppet.mpli.packetpub.com. Doesn't really matter, I can make it whatever I want. Alright, so with that setting in place, we're going to do puppet apply ini file.pp. And because the file doesn't exist, ini file is going to go create it and add the section for us. So now when I do puppet config print server, I'm going to get that thing that I was expecting. And indeed, when we cat our puppet.conf file, we'll see that the main section was added and this setting was added to it. So that's pretty easy. We could do that all day, right? We could just make as many resources as we wanted. We could set anything we wanted here. How about environment? So we'll do it in the agent section this time. Same path. the setting, environment, and the value I'd like to use is development, and close the resource, apply. Alright, and now when we do our cat like before, we can see that that's been added to the file. So that's a pretty nice thing to play with. But now INI subsetting, it can be a little more confusing, but let's try and do an example that might make sense. What we'll do is we'll make a report. And we'll do the store report first. So let's say that the section, this should be in the agent. The path, again, is going to be the same. Of course, we can just copy that. And the setting will be reports, the subsetting separator. Now, if you know the report setting in puppet.conf, that's going to be a comma. And the subsetting that I'd like to store in this area is the store. I'm going to be setting something reports, and I want store in there, and I want, if there's anything else in there, I want you to put a comma between it. So what we can do is we can do puppet apply ini file.pp, and now when we do our cat, we'll see that reports of store is there. But the idea with subsetting is that I could come right here, I could grab all of this, paste it, and then let's add a new report, say the log stash one. So we're going to come down, and instead of store, we're going to say log stash. And we're going to do our apply again. And now what this is going to do is going to add log stash to that list, but put a comma between it. So now we've got both of those. Now if I came in and added another one and ran Puppet again, because we're using the subsetting, Puppet won't care. It won't play with that file, it won't mess with it. But if I come back and I said, if I took out store and I only have logstash and HTTP, what it's going to do is going to notice that, and it's going to put store back in. Quite possibly at the end. Yes, so you can see it's put store back in, but it put it at the end this time. But the idea being that I'm only interested in the value, not the whole file. So I can play with this all day and change values like that. So with concat ini file line, it becomes really easy to manage parts of files. There is another utility out there, but it's included in core Puppet, so I won't talk about it here. But if you're interested in manipulating files, you should look into the Augeas provider as well. In this video, we're going to be talking about creating our own custom facts. And custom facts are written in Ruby and are part of the plugin sync mechanism that is now basically default in Puppet, but it used to be that you had to turn it on. And what this was that anything in the /lib or lib directory of modules was synchronized down to the nodes and run as part of their Puppet code. So basically, if you have a module in a directory, such as X, then x/lib/factor, anything in here would get synchronized down to opt puppet labs puppet cache lib factor. And when you run factor-p, all of those files get read. So everything in opt puppet labs puppet cache lib factor. That's when you run it as root. If you run it as yourself, it actually uses the .puppet labs directory, and since we're just testing right here, we'll do that here. So we'll go to .puppet labs, and then we'll go to the opt puppet cache directory of this directory, then lib, then factor, And we'll create a test RB file. And what we'll do is we'll use the factor.add. So this is how you create a new fact. We're going to create a new fact called test. We're going to wrap that into an end. And then we're going to use this set code. And all that set code does is make sure that whatever this statement evaluates to is returned as the value. So if I put 42 here and I say factor-p test, I'll see that 42 is returned. Now I can also just say 6 times 7, and again I'll get 42. So you can really do whatever you want here. You could say hi. And the nice thing is too that you can actually use this value right away. Let's make a test.pp file, and we'll say, based on the value of test, if it's equal to 42, I'll say so long and thanks for all the fish. Otherwise I'll just say don't panic. So if I do puppet apply test.pp, we expect to see the so long and thanks for all the fish. But if I make the test RB 42 plus 1 and run again, now it's not equal to 42, so I'll get the second one. So you can build your own custom facts and use this to augment your logic in your scripts. You can also use facts within your custom facts. So I've made an example of that here with this region fact. And again, because this is Ruby code, you can actually include libraries. So I'm using the ipadder Ruby library. And then I've created a function for myself that says get region. And I have a hash with 2 regions in it that are based on these 2 subnet masks. So it's kind of saying if your IP address is in this range, this /16, or if it's in this /8, you'll either be local or remote. Then I loop through this hash by going through regions.keys. And I say if the IP address that you passed in right here is included in that range, and this include is just a function that's provided by this ipadder library, I'm going to return the name of the zone. Otherwise I'll return undefined. Now this is where I'm going to use the value of IP address from factor by saying factor.value. So I can basically reference any fact by doing factor.value. So what I'll do is I'll create a new fact, I'll call it region, and then I'll do this function get region using the IP address that I got up here. Now obviously in production there would be a lot more error correction and things like that, but for the purposes of demonstration we can say factor-p region, and based on my IP address I'm either going to get local or remote. And if I do factor IP address, you'll see that I'm in the 10 dot range, which was in that remote. Now, the other mechanism of making facts is actually just to create files, and these files can just be shell scripts, they can be YAML files, or they can be text files. And these would be typically placed in the etc factor facts.d directory. Again, since I'm running just as myself and not root, I'll go to the .factor facts.d directory. So this is the local directory that's used when you run factor as yourself or as an unprivileged user. We'll start from scratch. So we'll make a YAML file. YAML file starts with 3 dashes, and then you can start defining things. So you just can say 1 is equal to you can say 1 is equal to 1, or 1 is equal to 2, or something like that, or 2 is equal to 3. You can also create arrays. You could say 3 is actually something like Mashu. You can also do hashes. So hashes is basically where you just start indenting and make another array. So you can get 4 is equal to, let's give it a key, something like So now this is a hash, so 4 will be a hash and 3 will be an array. So we can just go factor 1, it's going to be 2, factor 2 is going to be 3, factor 3 will be an array, and factor 4 will be a hash. And because I'm running a factor version of 3 or higher, you can actually reference these subfacts by just going factor 4.ichi, you'll get 1. For that song, you'll get 3. For the array, you'll have to use the subscripts. So there's 3.0 or 3.1. That's how you can use those. Now that was just a YAML file. I can also make a text file. So I can say that this equals that, that equals this, them equals you, that sort of thing. So another thing we can do is use script or an executable to make a fact. So if we make a script, and any executable will work obviously as well, we do have to make it, the output from this script, mimic the text file output. So what we'll do is we'll say that now equals, and then we'll make it run date. So now we'll do a chmod of this to make it executable. If we run this, we'll see what the output looks like that, which is great. And now we do factor for now, and we see that's the fact. So one last thing to say about factor from the command line is just that you can say multiple things and it'll return them in a list. And you can actually add a -j to make it a JSON or a -y to make it a YAML. And sometimes that's helpful for when you're working with other scripts. And that's all I wanted to say about custom. In this video, we're going to be talking about writing our own custom types. But before we talk about that, we'll just talk about defined types. And defined types are basically like subroutines. So the same way you would use a subroutine in any other language, you would use a define. And the best way to show it is to just make one. So you create a defined type by using the keyword define, then the name of the resource you want to create, and then basically anything you want to put in here will be reused. So we'll make a single notify resource inside our greeting, and then we would just use it by saying greet, and then we can say the name, and that'll be passed as the title argument. So that now if we go puppet apply find.pp, we'll see those two notifies come down. You can also have arguments up here. You can just say something like maybe the way you'd like to say goodbye to that person. So this would be an argument to this, and we'll say that it's by default goodbye. So now this now has an argument. So if we call it with no goodbye variable, we'll just get goodbye. But in this one, if we say that bye is equal to ciao and do our apply again, we'll see that we get the same output because we forgot to use it in it, didn't we? Of course. And we should wrap this like this. So we'll put the bye in, and obviously now it'll work. So we see that when we didn't pass an argument, we got the default of goodbye, but we got the ciao. To make it a little more obvious what is happening, let's add another resource to this defined type. So let's make a file resource as well, and we'll call it, we'll use the title argument as the path to this file. We use a here doc, and because I want the variables interpreted, I'll use some strings here. So I'll just start here, greetings. And I'll just paste some spam email into there. And then I will say that this is the end of my here doc. And then I'll end the file resource. So now when I run again, I'll get the notifications, but I'll also create the files. So now if we look, we have those files now. And of course, if I wanted to make another one, it would be pretty easy to do. So now I should get all three. And that's really how easy that is to do. You can create defines for multiple things, and they're very useful when you have something you want to do multiple times. So moving on to the harder thing to do is to create your own custom type. And to create our own custom type, we're actually going to use our Puppet server and a client node. So this is our client node. And here's our server. We're going to go into the modules directory, and I'll make a git repo module. And then I'll make a lib puppet directory. And in there, we'll create a type, and in this, we'll call it git repo. And what we do is just define the new type using the new type keyword here. This is the name of the type. Then we say that it's an insurable, and insurable means that it's something that can be present or absent. And using that means that we have to have a way to remove it and create it and check if it exists. I then add a parameter to this. I'm going to say this is the source parameter, and I'm also going to say that this is the name variable. So if you don't give me an explicit name for the git repo resource, I'll assume it's the source. And then I add a path variable. And that's really all I need. I just need to say that it's a new type, it's insurable, it has source, and it has path. So then I go into provider. You have to make a directory for git repo, because that's the type. But then we'll make one the provider of git, and we'll say, okay, the first thing we need to do is require the file utils package. Second one is, now we're going to actually explicitly talk about our git repo. So we're going to say, yes, this is a provider, this is the git provider for the git repo type. We're going to define our git command as just git. So this is going to look for git in the executable's path. And then, like I said, because we have insurable, we need to have three different functions. We need to have create, exists, and destroy. So if we want to create, basically we will do git clone, and then we'll take the source. So we'll do git clone and then the source, and tell it where to put it. So that's the path. So if you were doing this on the command line over here, this is equivalent to saying git clone, some repo into some other place like that. And then this is the exists parameter, and basically we're just going to say if there's a directory that exists where we expect it to be, that's good enough. I mean, you could check explicitly for this path and then .git. That's a little better, but this is really just a toy example, so we don't need to be too explicit. And then to destroy, basically just rm-r on that directory. So this is a little dangerous, but we are required to provide a way to remove it. So we need destroy, create, and exists. And then with these in our module path, so this is in our module path right here. Let's go to our environments production manifest directory, and then we'll go down, and after here we'll create a git repo resource, and we'll say that it's going to use this /srv/mpli, and then we'll have it place it in temp MPLI. So the first thing I want to do is just remove that directory if it already exists, because I want to see it created. And then what I want to do is make sure that that srv mpli.git exists. It is a repo, so let's just git clone srv mpli.git. Okay, so if we do MPLI, we'll see there's a README. Add it, say a commit. Alright, and then it's going to complain about my username, and then we're going to push to the origin master, and it's going to say great. Alright, so we've made that change, so let's do a puppet agent-t, and I'll also pass the debug flag, so that's going to produce a lot of extra output, but it'd be nice to see what it does. So this is what we would have got if we didn't do debug. It would have just said I created it, but here we actually get to see the command. So what it did was it ran bin git clone srv mpli.git into temp MPLI. So now if we cat temp MPLI readme, we'll see that it has the file that we expect. In this video, we're going to be talking about Hiera. And Hiera is a tool that's used to separate the data of your installation from the code of your installation. And basically with Hiera, you can create hierarchies of data based on facts. And using that, you can greatly reduce the complexity of your code by having a lot of the nested if statements or case statements handled by just having the Hiera tool return a value based on facts. And it's easiest to describe it in an example, so we'll show a couple examples. The first thing to do is to configure Hiera, and Hiera is configured with a hiera.yaml file, and that's usually in this directory here, Etsy Puppet Labs code. And if we look here, it's a YAML file, so it always starts with 3 slashes, and then we specify the backends. By default, there's 2 backends available, JSON and YAML. There are other ones available that can be installed. And if you wanted to use the JSON, you would just place it here. And if you wanted to have the JSON before the YAML, you would do that. Or if you wanted to have it after, it would do that. And the backends would be parsed in order. We're going to use the defaults for YAML, but one of the things you can set with the YAML backend is where to find the data. This is the default, so I'm just going to go with the default. And then the important thing is to specify the hierarchy, and the hierarchy is how Hiera is going to look up values. So when you go to look up a value, it's going to look for a directory, a subdirectory called hosts, of this directory. So it's going to go to Hiera data, then hosts, and then it's going to look up the value of the host name from factor. If it can't find anything there, it'll look in the arch directory, and then it'll look for the architecture of the machine we're talking about. If it fails both of those, it'll go and look for the value in common. So let's go look at that data. Change the file. Let's go to environments, production, Hiera data. We'll see there's common. And common has this message value. So what we can do is just say Hiera, what's the value of message? It won't be able to find it because our backend directory for the YAML specified the environment was part of that path. So what we want to do is actually tell it that the environment is equal to production. And if we do that, it can find this message now. Now, if we want to have another message appear based on something else in the hierarchy, we can go to, say, the arch directory that we created, and we can create an x86-64 YAML, because when we do factor architecture, that's what we get back. So we're going to do x86-64.yaml, and we'll create a message here that says this is the 64-bit example. Again, when we do this, we'll see that it didn't actually work, right? Because we didn't tell it what the architecture was. So let's do that. And if we do that, we get the value that we're expecting. And a nice way to use Hiera from the command line is to create a fax file for yourself. And you do that just using factor. So you can say factor, and you can say -y for a YAML file or -j for a JSON file. And then you can just redirect that into a file. And then you can tell factor to use this file to look up the message in the environment of production. Now again, we're not going to get the 64-bit one here because the factor utility, when I do factor architecture, I get x86-64. But, and if I do factor os.architecture, I also get that value. But when I look at my JSON file, I'll find that only the os.architecture is defined in the output file. And this is really just the way that that output file is created. So you have to be aware of this inconsistency. You can also just place this value in here by saying architecture is x86-64, and then need a comma above. And then if we do our example where we were loading the file, we'll see that we get the 64-bit now because that value was set as we expected. And another nice thing to use with Hiera is to have things looked up automatically. And to do that, let's create a test message class. And we'll just say that the test message class has a notify where it just prints out the value of the message variable. And we'll include that. So this is a complete manifest that defines that class and then includes it. So if we do puppet apply test message.pp, what's going to happen is we're going to include that class. It'll have the notify that just has that one message in it that says testing. The really nice thing to do with Hiera is to have that class variable, that parameter that's being passed to this test message class, looked up automatically in Hiera. So what we can do is we can go back to Hiera and we'll do etc puppet labs code environments production and Hiera data, and then we'll go into common.yaml, and what we want to do is take the name of this class and the name of the variable and stick that into Hiera. So let's do that. It's test message is the class, 2 colons to separate, and then message is the variable. And we'll say this is an automatic Hiera lookup. And then we'll run our manifest again. And this time when we run it, it's going to look up that value in Hiera and it's going to spit it out here. And the idea being that we could have that value returned based on facts on the system. We could have a specific host name file created that has a different message in it. And we can do that now. So if we go to etc puppet labs code environments production and then Hiera data, we'll make a directory called hosts. We'll see what value of the host name is on here. It's puppet, so we'll create a puppet.yaml and we'll do the same thing. We'll start with making it a YAML file, then we'll say test message : value of message, and this is the puppet specific message. Okay, and then we're just going to apply. We have to go back. And now, based on the value of the host name, that's going to go and look up this value in Hiera in that other file. And as you can see, that's the output that we're getting. And doing these sort of tests, you'll get more familiar with how Hiera works. But this is a very powerful utility because you can have your classes defined in one place, but then have certain values pulled out of Hiera based on whatever facts are on the system. And the last thing I want to talk about with Hiera is Hiera include, which is another function you can use. So we did an automatic lookup, we did the command line. You can also include Hiera in your manifests. So if we look at this hiera.pp, I can say I can use the Hiera function to define a variable. So I'm going to look up a value of message in Hiera. Now, if there's nothing found in Hiera, I'll use this default message of no message. And then I'm just going to put a notify out. So if I do puppet apply of hiera.pp, you'll see that I get that 64-bit that we were expecting. Now if I come back in and I look up something that doesn't exist, like that, now I expect to get the no message because it couldn't find anything in Hiera. So we got the no message value that we expected. Now the other thing I wanted to look at is using Hiera include. So you can say Hiera include and then say what you want to include. I'm gonna look up something called classes, and if I don't find anything, I'm going to include standard lib. So now what happens when I do this is I go puppet apply hiera.pp. It's going to go look in Hiera, see if there's anything called classes, and anything that's in classes will get included. Now it didn't find that, so it's only going to include the standard lib for me, which is not a big deal. And usually what you would do is actually place this in your site manifest. So let's go look at that. If we go to Etsy Puppet Labs, code, environments, production, manifests, and we look at site.pp, what I can do is create a default that just includes classes, and if it can't find it, it includes standard lib. And then if I go over to a node, we're on the node here. If we just do puppet agent-t, we expect that if it can't find anything in classes, it's just going to include the standard lib. And if we look in our classes.text, so we'll just cat that, we'll see that standard lib was indeed included, but we want to include other classes. So let's go back to our Hiera data. So we're going to go into Hiera data. We'll just do this in common for now. We'll do classes. So we're defining classes, and then we want to say, what do you want to include? And we want to include the base class. So we'll go back to our node now that we've made that change, and we'll do puppet agent again. And this time we should get the base class. Now the base class just includes a notify on this system, but the notify lets us know that we do have the base class. And I have another one there, so I'll just include it. And actually I can include it somewhere else in the hierarchy. So let's put it in the Arch directory. So let's create a classes in here as well. And we'll include the another class. And let's run our puppet agent, and now we expect to get the base class and the another class. So we got the another class, which just has this useless notify, and we got the base class. And if we look at our classes.text, we'll see that we got another and base included here. So using Hiera, you can really simplify a lot of your manifest by putting a lot of the logic into the Hiera lookups. So any of those huge case statements or nested if statements, they can all be handled by Hiera. And that's the end of this section. So if we wanted to use the ensure absent, the first thing we have to do actually is go and fix our destroy. This is wrong. I need to make this file utils. Alright, which is why the whole reason we included the file utils at the beginning. And then we need to go to our site. So we're in this directory. We need to go back 1, 2, 3, 4, 5, 6, and then into manifests and into site.pp, and we're going to change ensure to absent. Right, so that looks good. So then if we come on to our second machine, if we look at temp and PLI, it's got that. Let's do a puppet agent-t. We'll see that the provider was updated and that the ensure was removed, so that now when we look at temp MPLI, there's no such directory, it's been removed. And that's how we would use the absent, which uses the destroy. In this video, we're going to be talking about Puppet reporting. And reporting in Puppet is handled by the node and the server. Now the node has to be configured to send reports, but this is the default. So even if you don't have a report setting in your configuration file, which if we grep for report in our puppet.conf, we'll see we don't have a setting, but if we look for the setting with config print, we'll see that it's set to true even though we have nothing set. So that's how the node is configured. It just basically sends a report or doesn't send a report. It's up to the server to decide what to do with the report, and that's handled by the reports setting in your puppet.conf. So if we do a puppet config print, reports in the master section, we'll see that the default report is store. We don't actually have a line in our configuration saying that. That's just the default. So that if we run Puppet on this machine, and I have this configured just to do a empty manifest that does nothing, so that it's a bit quicker, we'll see that if we go to this directory, the opt Puppet Labs server data Puppet server, there is a reports directory, and then there's a directory for each machine that connects. So we have one for our MPLI machine. And if we look, we'll see that there was a report written just now. And actually that config version 147.122.4010, we can grep for that number in this last file, and we'll see that that's the configuration version of this. So that's how you use the store report method, and basically that just dumps the YAML file. You can use any other report out there that you like. There's quite a few of them. There's an IRC one that'll send it to IRC. There's also an HTTP one which will dump it to an HTTP endpoint, and I'll show you how to do that right now. So what we want to do is go to our Etsy Puppet Labs Puppet directory and edit the puppet.conf, and we'll come down here inside the master section and we'll say that reports is going to be equal to HTTP and store, and we're going to use this other setting, report URL, and we're going to tell it where to store the report. We're going to have it actually go to our MPLI machine on port 8000. Now because we made a change to that setting, we're going to have to restart. So we'll tell these reversed. Restart Puppet server. Now that'll take a few seconds. So what we'll do is we'll come over here to our MPLI machine, and I've made a quick Python server that can be used to deal with the post method. So I'm going to import YAML because the Puppet server is going to send us YAML, and what we're going to do, we have to do a little bit of funky things here because the YAML that Puppet sends out has these Ruby objects encoded in it, and Python doesn't know how to deal with those. So we're just going to tell it to just use them as is. Don't try and do anything special. So that's what this code here is talking about. And then the post method is what we're most interested in. So what we're going to do is we're going to read all the data from the post, and then we're going to load it as a YAML file, and then we'll be able to use parts of that. So we'll just print a message saying we received the port, and we'll then save the entire data out to a file that's named after the configuration version that we received. And then we'll close the file. We should do that. Yep. We'll write the data and then we'll close it. So what we want to do is start this. We'll just do Python server. We'll tell it to listen on all IP addresses on port 8000. Alright, so now it's listening on port 8000. And hopefully the Puppet server has restarted. Okay, the Puppet server is restarted. So now we'll do our Puppet agent -t. And then once it sends the report, we'll see a line here telling us that it's received the report. So it received the report for MPLI, and it saved it to this file. So let's take a look. That file. Oops. So there's that file that we just created, and if we look at it, it's going to be very similar to the one that we had from the store backend because we're doing the same feature. We're just grabbing the YAML file and storing it. That's how easy it is to set up reporting. In the next section, we're going to look at using Foreman, which is we can use the Foreman's report manager. And that's all for that section. In this video, we're going to be talking about using the Foreman and specifically using the Foreman's reporter with our current Puppet installation. And the easiest way to do that is to install a Foreman. Just do the vanilla installation following the quick start guide here. If you're going to do a CentOS or a RHEL-based distribution, you'll want to make sure you have the EPEL repo installed first. Then install the Foreman's repo RPM, and then run Foreman installer. And once Foreman installer is done, you'll have a Foreman machine up and running. And then what you'll want to do is create a certificate for your Puppet machine, and you would just do that with Puppet certificate generate, and then puppet.example.com. and set the CA location as local. Now I've already done this, so this will not work. But once you do this, you would then sign the certificate. And once you have the certificate, what you do is you would copy it over to another location on your Puppet server. Now in my case, what I did was I went to the Etsy Puppet Labs directory and I made a Foreman directory. And if we look in this directory, we'll see that what I did was copy the private key and the public key, the certificate, and the CA certificate from Foreman. So these are the ones from the Foreman machine. And I just stuck them out of here to make sure that there was no confusion as to which one was which. The next thing you would do is then come in to Etsy Puppet Labs Puppet, and there's a foreman.yaml file. And what you want to do is copy this file over to your Puppet machine. So we've already done that. The location has to be the same, so it's Etsy Puppet Labs Puppet. And then what we're going to do is come in here and we're going to point the CA certificate and then the certificate for our machine at the directory that I just made. And then the last thing I want to do at the end of that is go to this Etsy Puppet Labs directory and just chown all the files to the Puppet user so that all the files in that Foreman directory are owned by the Puppet user, because that'll be the user that the Puppet server is running as later. Now, the next thing we have to do is go to the Puppet directory, and we're going to enable the Foreman report. So if we just look at our puppet.conf, we want to make sure that we enable the Foreman report right here. So I'm using the store one and the Foreman one. Now the last thing I have to do is then copy that Foreman report file into the appropriate directory. Now I could do that by either using plugin sync, or I could stick it in the correct location for Puppet reports. I've elected to just stick it in the correct location. So if we do an update db, and then we'll look for foreman.rb, we'll see that this is the location for that report file, which we got by copying it from Foreman. So if you just straight copy that report from this location to this location. So same thing on this machine. we'll see that there's this report file right here that's installed by the Foreman installer, and all I did was copy that file directly over to this server. So we're almost done. The next thing we have to do is then log in to our Foreman dashboard and come down to the Administer menu and go to Settings. Now under the Auth tab, you have to come down to the setting for, move that down because it's a little off screen. There we go. Alright, so we have to come down and just say what are the Puppet Master hosts that are trusted by this Foreman, and we want to add the host that we just created. Otherwise, Foreman will reject the reports that get sent here. And this little help message basically tells you that same thing, that you need to put the hosts in here that you trust for sending reports, or proxies if you use Foreman proxies as well. So I've already done this. You would just come down and add it by hand, but I've already done that. So I'm saying that I'm going to accept a report from this machine. So now if we go to all hosts, we'll see that there's only the Foreman machine itself. But now if we go back to our MPLI machine and run Puppet agent-t, what'll happen is that our run will finish, and now you'll notice that it says it's already finished and applied it, but there's that little delay at the end. That delay is when this Puppet server is sending that report over to Foreman. So if we go and look on the Foreman, we'll see that there's now an MPLI machine that just checked in, and then we can see the reports for it. Now obviously there's no resources in this report because the manifest was empty, but let's just go and make something. Code environments production and manifests, and we'll just create an empty notify. And with that in place, we'll go back to our MPLI machine, run the agent. We'll now get a new report sent, and we'll also have a notify in here. So here's our notify. So if we come back to here, we can see that there's one report. When we reload, we should see two reports. So here's our two reports, and then we can see that there was one application, and that resource was just a notify resource. We can also go look at the reports. So we can see that this is the report that we just saw. There's one resource that was applied. The time is not set up between my two hosts, so I have to fix that. But as you can see, here's that empty notify that I said. So using Foreman's API or GUI, you can get a lot of nice metrics and a really nice GUI for free by basically just installing Foreman and then pointing your existing Puppet over at it using the Foreman report processor. In this video, we're going to be using PuppetDB to store reports, similar to the way we were using Foreman before or using one of the other report processors. PuppetDB has its own report processor, which will just store the reports in PuppetDB. Now, if we go and look at our Puppet Explorer, when we went to look at the nodes, we don't actually see any information about them because their facts will be there, but the reports aren't there. So everything that's displayed here will not be shown because there's no report. So to enable that, we go onto our Puppet machine, and there's a couple files that have to exist. We need a puppetdb.conf and we need a routes.yaml. The puppetdb.conf basically just tells Puppet where to find PuppetDB. So it's going to look on this PuppetDB machine. And then the routes.yaml just says that PuppetDB is going to be the terminus for facts. To get the report working, we're going to look at puppet.conf. Now obviously, if we want to actually use PuppetDB properly, we're going to set the store config setting and the store configs backend to PuppetDB. But now in the reports section, we've also added PuppetDB, so that after you restart the Puppet server, it will now know about the PuppetDB report and send it there. So if we run our agent here like we've done before, When it finishes, it's going to send the report. You can see that it's already come back. So it sent the report here. So now if we come back to Puppet Explorer or any one of the other GUIs that's available and reload the page, we'll see that now MPLI has just checked in, and we saw that it had one success, which was that the notify statement that we had right here, this notify. And then if we click on the report, it'll show us that in more detail. Basically, it'll just say which one happened. And we can also verify that by going into the database. So if we go to the PuppetDB machine and we log into Postgres, we can just say select all from reports. So we can see that there is one report in here for the machine mpli.example.com. Here's all the resources from that report, and the notice is there at the end, and then the applied catalog. So this is basically the report inside the database. And that's all there is to use the PuppetDB report backend. It's actually quite simple, and it's fairly useful if you have one of these GUIs attached to it, because then you can see if things are good or bad just by running one of those backends and then looking at them all. So now any of my other nodes that would check in now would actually send a report, and then I'd see them here and I'd be able to look at them. And the dashboard actually becomes a little more useful when you have the report processor in place. It tells you a little bit more information. That's about all I wanted to say about that one.
In this video,
we're going to be looking at one way to use report processors to monitor your systems. And the nice thing about report processors is you don't have to run them for all runs. You could run them for just failed runs or something that you're specifically looking at. And one of the nice examples out there is from James Turnbull. He wrote an IRC report processor that only sends failed runs to IRC. And what it does is it basically logs into your IRC server, sends a message, and then logs back out again. But if you have everyone in your organization logged into IRC anyway, they'll get a nice notification when things go wrong. And this report processor is still available on GitHub in his personal space, and it's called Puppet-IRC. And it's reasonably easy to install. He's got an installation help here, but basically what you want to do is download the module, and I've already downloaded it to this directory here. So this is the module directory, and then what you can do is you can apply this by saying, include the module path of this directory and then your normal directory, and then run this IRC install IRC pp file. And what's in this file is just a instantiation of the IRC class, and then I tell it where to log into, the username and the password, and then this is the server, irc.example.com, and then which channel to log into. And I've renamed this to my Puppet channel. So what this does is it creates an irc.yaml file in the Puppet Labs Puppet directory. You can see it installs with this username, password here, and then it's going to log into the Puppet channel. So the idea being that you would run your agents, you would log into your IRC server. I'm using IRSSI here. I'm going to join my Puppet channel. You see this is my Puppet channel. And the theory is that I could be running many nodes, and all of the successful ones I'll basically ignore. So we'll wait. This one, so I've run it twice here, and you'll see there's no messages in here because these were all successful. But if we go into our environment directory, and let's just make sure that all the nodes fail. So we'll say they fail with and this is just using the fail function. With that fail in place, so now when I run my Puppet agent, it's going to fail. You can see it failed. But if we come over here, we can see that the report processor logged in as the user Puppet bot, and then it sent this message that the run in the production environment for mplexample.com failed, and that I could then go and look on Foreman if I had Foreman set up, and this would show me that report. You can obviously modify this URL, but the idea being that if you were logged into this channel as a normal day-to-day thing, only your failed runs would come in here, and then you could actually do something about them. And that's one way that reports are actually very useful, is if you hone in on just one little thing or one specific thing that you're looking at, in this case looking for failed runs. This would actually make it a lot easier for you, because you'd be trying to get rid of all the failed runs, because this would interrupt the flow of your conversation and you wouldn't like that. That's all I wanted to say about that.
In this video,
we're going to be talking about how to check the syntax of our code. And there's two tools we can use to do this. We can use Puppet lint, or we can use Puppet parser validate. Puppet lint is a linter, which basically checks to see if the code is formatted properly and follows a bunch of rules. And it's available from puppetlint-com. And it does a series of checks on your files to see if they pass a lint test. So let's see, if we had this test file, it's just a simple class that has a single notify in it. But if we did Puppet lint on it, it would complain that the class is not in an auto-load format and it's not documented. Now, you can disable any test by finding the name of the check and then using the disable line for it. And you can go to the checks part of the website to list all of these checks. And the one that it complained about there was the documentation one. So if we go to the documentation one, we can see that by adding no documentation check, we'll get it to disable that check. So if we just add this to our command line, we'll see that instead of getting the 2 errors, we only got the 1 error this time. Now the other thing is, let's say we did another notify, but we also put double quotes around it. Now when we do our check and we disable the documentation check, we still get this one. But if you knew, for example, that you needed to do that, you could disable a single check by using a control comment. So you can say lint and then ignore, and then you need the name of the test. So you can come back to the checks and look for the one about double quoting a string containing no variables. And down here it'll tell you how to disable it. So you basically take the name right here, double quoted strings, copy that, and then say you're going to ignore, and then you're going to ignore double quoted strings. So that now when you come back and you say to disable that one check, the other one is disabled with the control comment. So now you have those guys disabled. So if you had a reasonably nice formatted file, like let's say we have this one here, which is talking about our good class. It has a notify, it has an exec with a very long path, but I've told it to ignore the 80 column limit that it usually looks for. So if I try Puppet lint on this file, you'll see that it comes back right away with no errors, and it has a good exit code. So knowing this, you can use Puppet lint to check your files as you commit them into your repository. So let's say this syntax is actually a Git repository, and let's say we've added this test.pp file. When we go to commit the file, we can see that our pre-commit hook for Git had it run puppet-lint, and puppet-lint errored, therefore our commit errored, and we're still stuck here. We can't commit until we correct the problem with that file. And this is done with a Git hook, and there's lots of examples out there how to do it. This is by far the simplest one I've written, just as an example. But if you go into your Git directory, into the hooks directory, there's one called pre-commit. This file is extremely short. It's 23 lines long, but this is really all this is the meat of it right here. Is basically I'm saying, give me a list of all the files that have been added, and then if the file name ends in pp, and this is just a bash 4 shortcut for figuring out if the file ends in .pp, then run puppet-lint on the file, and if this exits cleanly, move on to the next file. If it doesn't, then we're going to exit the entire script with the error code of this file. And that's how you can write a very simple script that will now prevent you from committing code that might not pass a lint check. The only problem with that is that when we did puppet-lint on this test.pp, it really didn't point out any big problems with this file, because if we look at this file, we're in the wrong directory. Right, so if we look at this file, it's actually missing the colon here at the end of the title of these two notifies. So that's when you want to use puppet parser. So if we do puppet parser validate and then gave it this file, it would complain that there is a syntax error right here on this file on line 2 in column 16. And so we can just come into this file, test.pp, we can come in plus 2 lines, 16 columns over. And it's going to say, well, you're missing the colon right here. If we put the colon, the only problem with the puppet parser validate is that it's going to only find the first error and exit, because now we see that line 3 also has a problem. So if we want to come in to 3, now we're on this line, and we know that right here, this one in position 16 is where the error is, and it's basically that we're missing the colon. So now if we come back down and do our validate, now we can see that this file validates properly. So what you would want to do in your Git commit would be to run both checks, to run a puppet-lint check and a puppet parser validate check on the file. And you can just do that by adding it into the hook. Same problem we had before. We're going to actually exit because of the puppet-lint error, but that would be what you would do to get both checks run on every file. There's a bunch of other checks you should probably do at this point too, like if you had YAML files, you'd want to validate that the YAML's the correct syntax. Any other like ERB templates, you can run them through ERB and get it to tell you whether or not the ERBs are in the right syntax. And that's just a good practice so that you don't end up committing things that have errors in them. You can, of course, bypass the entire thing by saying git commit, give it a name, and then telling it not to do the check. And then it's going to do it. So this -n basically ignores your pre-commit check. In this video, we're going to be talking about using RSpec Puppet to create tests for your code. And I'm going to just make some very simple examples so that you get the idea of how to use RSpec. You can build very complex examples, but starting small usually makes it click for people for what you're actually supposed to do. And the first thing you need to do is install RSpec Puppet. And the way you do that is with the gem installer. So if we look at my history, we'll see that I usually do this with the gem, the Puppet Labs gem installer. So I do Puppet Labs gem, and then I install rspec Puppet. And then there's a few other things you need to get this going properly. You'll need the Puppet Labs spec helper, which creates the spec helper class that's used by the module. And then this is actually wrong, but this is the one you want, the metadata JSON and Rubocop. And when you create a module, when you go Puppet module generate, it populates the spec directory for you. So I've got an rspec test module that I created using the Puppet module generate, and you'll see that it created this spec fixtures directory, and it also included the spec helper file for me. And that spec helper file that it creates references the Puppet Labs spec helper, so that's why you need Puppet Labs spec helper here. But with that in place, what you can do is go ahead and make your module like normal. So in this module, we have it do nothing really interesting other than we have it have a class variable of foo. And then I have a case here, and if the case for the OS family, if it's Red Hat, I'll make a notify that says Linux, and if it's Windows, I'll make a notify that says Windows. And if it's something else, I'll make it notify with something else. So that's the first test, is I just want to see what happens when I do that. So the way I test this is, so we're going to say that if the OS family is Red Hat or something else, we're going to get either Linux or something else. So how this works is we'll go to the spec directory, classes. Now there'll be a file here. This one here, init spec, refers to the init class of my module that we're in. So if we look at that, we'll see that I'm gonna require the spec helper, which is the file in one directory above. Then I'm gonna say, okay, I'm gonna describe this module, and now I'm gonna create a context. And the name of this context can be anything you want. It can be foo, it can be whatever. We'll make it foo just for fun. What you want to do then is describe the test scenario that you're going to be doing right now. So we're going to talk about a machine where the OS family is actually set to Debian. Now, because my test was for Red Hat or Windows, Debian would fall down into the something else. So I would put something else here. So I would say it should contain the class rspec test. It should contain the notify something else. It should also contain the notify foo was default. And this one down here is for later. I also created another context, but we'll comment that out for now. So we just have the one context with 3 conditions in it. Then all we do is, because we go back to the top directory of our module, and we have a rake file here that was created that includes the Puppet Labs spec helper and has all of the tests ready. It also requires Rubocop right here, so that's why we needed Rubocop. But what we can do is use rake, because we have the rake file, and just say rake spec. And that'll run the spec test on our module and let us know. So we had 3 examples, we had 0 failures. That means everything worked. We had the 3 tests work. If we wanted to see what it looked like when it failed, let's go to spec classes, init spec, and let's change this from something else to just something. So we know that the notify that we were going to get was something else. So this will fail because there is nothing called something. So we can see we had 3 examples, but one of them was a failure. And the failure was that we were expecting it to contain the notify something, but it didn't. This is how you can basically build up your tests, is just coming back and modifying this and making it until it's right. Now, if we had the right test here, if we had something else here but it failed, if we didn't actually get the something else, then we'd have to go back at the code and figure out why when the OS family was Debian we didn't get what we were expecting. Now let's try creating the other instance where we're going to create another context. The context can be called whatever we want. And we're going to say, in this one, the OS family is Red Hat. And it should contain the class RSpec, but it should also contain the notify for Linux this time, which is what we expect. So we can do break spec and test that. We'll now get 5 tests and no failures, which is great. And you can build up more complex tests. If you go to the RSpec page and you come down to matchers right here, you'll see that these are all the types of tests you can do. You can say, can it contain a user? Can it contain a file resource? With is interesting too, because you can say, well, it's expected to contain the service Apache, but it's also supposed to be running, it's supposed to be enabled, it's supposed to have restart. So you can make your tests far more complex, but starting simple is usually a much better way to work at this. So let's go back to our spec classes. And in here I had this test. It should contain the notify. Amazing! And that's because if we go back, I'm going to include that test now. Now if I run it, it's going to fail because it doesn't contain that. And the reason it doesn't contain that is because if we look at my manifest in it, I have this other test down here that says the variable foo. If foo is not equal to default, and default is the default value that's assigned, then I'm going to print out a notify that says the value of foo. Otherwise, I'm just going to have this foo was default notify. So I'm looking for the value of foo. And I'm going to pull that out of Hiera. So the way to get that working, to have Hiera work within your spec test, is in the spec helper file, you just define a Hiera configuration. So I've already done that, but we'll have it commented out again. And all I'm going to say is look in the fixtures directory for a hiera.yaml. So if we go to spec and then fixtures, we'll see that my hiera.yaml references the local spec fixtures Hiera data directory, and my only hierarchy item is common. So if I look in Hiera data common, I have that. I only have one value in this Hiera data right now, but I'm saying that the RSpec foo variable has the value of amazing. So if my RSpec test is able to look up in Hiera this value, I should expect to get a notify that says amazing. So now when I go back to the module and I say rake spec, it's going to look for that amazing notify, and it's going to find it because it looked it up in Hiera data. Except it should contain the notify foo was default, and we didn't get it. And that was because of the second test. So let's go look at that again. Spec, classes, init. So we need to comment this one out because we don't expect to get that here. We do expect to get amazing, but we don't expect to get foo as default. That's how you can look up things in Hiera with your RSpec test. Now you can make your RSpec tests much more complex, but starting with something simple where notifies or file resource is another good one, and just work your way through the logic of it before you make it more complex. The idea being that you can have multiple test scenarios for things like Debian, Red Hat, all of those things without actually having to build it out on machines. You can just have it pre-populated by going into your spec classes and then going to each one of these files, and in this facts here having multiple facts defined. So you could have other facts in here like kernel, and you can build up basically a description of a machine and have it run through so that you don't actually have to have the machines. You're basically looking for problems that might arise from combinations of variables and whatnot that you're not expecting to see. That's about all I want to say on RSpec. In this video, we're going to be talking about Beaker, and Beaker is an acceptance testing tool that you can use with Puppet, and its home page is in GitHub under the Puppet Labs organization and then Beaker. And this repository, in addition to containing most of the code for Beaker, it also has a lot of documentation. It has a couple tutorials and a couple how-to guides. And when you're first starting out, the tutorials are probably the best place to start, specifically the one that tells you how to write a test, because that's the main thing you want to do with Beaker. And the idea of Beaker is that it's like server spec, but it also does the provisioning part of the machine as well. So you want to be able to provision a machine or a number of machines, and then once they're up, do something to them, like provision them fully, like do the install of the software, but then also test that it worked at the end. So the idea is that you would say start a service on the machine, but then verify that that service is actually listening in a meaningful way. So to do that, we'll just go over my really simple example. The first thing I did, so this is my Beaker directory, and I've created this configuration file here using Beaker. I've just told it to create this file for me, and if we look at that file, you'll see it's very simple. It basically says I'm going to be using Vagrant as my hypervisor, and this is the box that I want to use, and then whether or not I wish to mount some folders. And this would be useful if you wanted to, say, have a module directory synchronized up to the machine, or some manifest directories, that sort of thing. The next thing is your provisioning file. And this provisioning file I've made here, I could have it work with files that were synchronized onto the machine after it was started. In this example, all I'm going to do is make sure that HTTPD is installed and running. And then I'm going to use that in my test. So this is my first test, and my test is just basically, because it's CentOS 7, I'm going to use system control, and I'm going to restart the HTTPD process twice, and then I'm going to make sure that there's an HTTPD running. So I'm going to do this PS, I'm going to grep for HTTPD, and then I want to make sure that there's more than one. So this is the greater than, so that there's more than one HTTPD process running, because when HTTPD runs by default, in the default configuration, it has at least 4 processors running. So this test will basically tell me, yes, HTTPD is running. And the way I would test this is to run Beaker, to tell it that the pre-suite, that's the provisioning section, is in this file. The tests that I wish to run, I'm going to run this test.rb that I've created. And then I'm going to tell it where to find the hosts. So I'm going to say it's the CentOS host file. And then I'm going to actually do another option that I suggest doing when you're first starting this, is to say that you wish to preserve the hosts once they've been built. And once you do that, Beaker will start by creating a directory for itself to work in, creating a Vagrant file in there, and then running a Vagrant up on that. So this is now Vagrant running. Vagrant will import this box for me. Once it's up, it's going to then go through the provisioning steps. And once the machine is actually up all the way, it's going to apply that manifest that we had in the provision suite. And depending on your system, this may or may not take a few seconds. It's as it boots the machine. So now it's doing that copy of files that I had in my Beaker host file. Once that's done, it's going to run my provisioning steps. And generally, this is not the sort of thing you would watch. You would run this and then walk away, get some coffee, maybe come back a lot later. So here's that manifest. So now it's done, and we're back. Now it tells us up here that This is the provisioning step. There was only one test. It passed. That was basically running my manifest, so that's great. Next thing I wanted to do was make sure that HTTPD was running, and that is indeed working as well. Now I also told it to keep the machines. Remember, I said preserve hosts. So now if I do a find on the .vagrant directory of this directory, you'll see that there's a number of files that it's created, but it's created this vagrant file in this directory. So if we change to that directory, we'll see there's our vagrant file, and now we can do a vagrant status, and the CentOS box that was defined will be running. And we can do a vagrant SSH into that vagrant SSH. There's only one machine defined in the vagrant file. So now we're into this box, and we can see that HTTPD is running. The other thing we might want to do is check that LSOF is installed. The other thing you might want to do is just check that port 80 is listening, which we expect it to. So what we can do, because we know that port 80 is running or listening, we can make another test. So if we go back to our Beaker directory, this is what our test 2 looks like. And we can basically go, we're saying what is the port open is port 80. And basically you can build up a bunch of tests using this. And the way you would do that is just either by telling Beaker to look through an entire directory right here, or just putting a comma and then saying running test2.rb like that. Now anytime you run these, even if you have the preserve option, the next time you run it, it's going to remove shut down the one you had running and destroy it and start a new one. So you can only keep one set of virtual machines around at a time, and that's actually quite helpful. And that's about all I wanted to say about Beaker. And in the next section we're going to be talking about Test Kitchen, which is another level of abstraction higher than Beaker. In this video we're going to be talking about Test Kitchen, and Test Kitchen came out of the Chef project, and it does support both Chef and Puppet and other things such as Ansible. And it's a little bit more polished than Beaker. It's basically the exact same tool as Beaker. It's just been around a little longer, and some of the inner workings of it are a little bit more complete. One thing that's really nice about it is this is the homepage for Test Kitchen, kitchen.ci. But it actually uses this thing called Kitchen Busser, and there's a bunch of projects in here. You can do Docker backends, Vagrant backend, Cloud spec, but there's also Kitchen Busser. Yeah, so if you look, this Busser is basically a framework loading template so that you can use really interesting things like Cucumber or Bats. Bats is a bash thing, which is kind of nice. It's a bash testing framework. There's mini test, there's obviously server spec, and all of those fun things are there too. R spec and everything. And they're all supported out of the box with Kitchen, which is pretty nice. But to get started with Test Kitchen, we'll just make a directory. This is our Test Kitchen directory. And what you would normally do is just go like bundle init. It's going to say I already have a gem file because I already did this directory. But basically all that would do is just make a gem file. And what I wanted to include here was Test Kitchen and Kitchen Puppet. And with these guys installed, all you do is a bundle install. I've already got all my bundles installed. Once they're all installed, you can then just do kitchen init. Now I already have this installed, so it's going to say, do you want to override it? I'm going to say, sure, why not? So what it's done here is it has created a .kitchen YAML file for myself. So let's go look at that file. So this is a blank one. Now, actually, when I did this, I should have told it that I want to use the Puppet provisioner. So I'll say that I want to use the Puppet apply provisioner. It's going to do the same thing. Now when I go into my kitchen.yaml, it's going to say that it's going to use Puppet apply now, but it's going to be missing a few things. So let's go put those things in now. We need to go tell Puppet where to find its manifests. So let's do that. Manifests path is just manifests. The modules path is in modules. And the Hiera data path is Hiera data. Now I'm probably not going to use Hiera data, but those are the three things I want. I don't really need, I have no run list and no attributes. I can take these off, but I'll just leave them blank for now. And these are the test suites that I'm going to run. You can have multiple test suites. The default one is just called default, but we can make a bunch of them. And these are the two machines that I'm going to make. I'm going to make one Ubuntu and one CentOS. So now that we have our kitchen file in place, the next thing we want to do is make a Puppet file. So we'll make a Puppet file. Now I've already done this, but you would basically just make a very simple Puppet file that contains the modules you want to install. For this test, we're going to be testing NTP. NTP requires standard lib, so I'll just install both. I'd go r10k Puppet file install. This will create the modules directory. Inside there, we'll have NTP and standard lib. You'd then make a manifests directory. That's the one we specified, manifests, earlier. And then you just say, what do you want to include? And I'm just going to say, include the class NTP and set the servers to this. So that's all you'd have to do. At this point, you could then just do kitchen, which will create the machines and try to provision them. Now, if you've already done this, what it'll do is it'll go and destroy the ones that I have and create new ones each time. This can take quite some time. So it's already done the Ubuntu test, and now we're moving on to the CentOS test. It's going to run Puppet apply. It's going to tell us whether or not it worked. Alright, so everything worked, and all this means is that our hosts have been provisioned, but we haven't actually done any tests yet. Now, in that test directory that gets created for us, so let's go there, tests, integration. This will be, it'll just have this default directory. Now, what I've done is I've made a directory called server spec, and I put my server spec in there, and that's all I have to do to get server spec to run, which is really nice with Test Kitchen. If I wanted to do a bats test, I would just make a directory called bats. If I wanted an rspec one, I'd just make an rspec one. So that's pretty nice. And then what we'll do is we'll make a very simple NTP spec. We'll just say that the package NTP, it should be installed, and then if our OS is either Debian or Ubuntu, we'll make sure that the NTP service is running. Otherwise, if it's a Red Hat, we'll make sure that the NTPD service is running, just because the two OSs have a different name for the service. So that's my spec test. So now all I have to do is go back into the top directory of kitchen, right here, and then just do kitchen test. And what it's going to do, it's going to destroy the instances, recreate them, re-provision them, and then run the spec test against them. And if that succeeds, we will have a successful test. And this will take even longer than the last command, because it's got to recreate the entire machine. And this is not the kind of thing you usually sit around and watch. You usually kick this off in the background and then just wait for the results. It's now installing Puppet. And it's installing Chef. Like I said, you get Chef for free, whether you want it or not, just because it's very integral to the project. Alright, so it managed to install Puppet. It then is going to apply the manifest where it's going to install NTP and make sure that NTP is running. Once that's done, we're going to install server specs. Server specs then going to run against the spec file and tell us if it succeeded. There, it succeeded. So that's the end of the Ubuntu test. Now it's going to go on to the CentOS test, which will take a little while, but we'll come back and check on that in a minute. So let's go into another directory. And in this directory, I've done all the same steps. I have all the same files, but What I've done here is I've included the Apache module instead, and then I've gone to in my manifests, I've included the class Apache, and now I'm creating a vhost for MPLI, and I'm telling it to listen on port 8080. Now I'm purposefully missing this doc root setting, so I'm leaving that out right now, and I'm just going to see what happens when I say kitchen converge. And this is part of the idea of Test Kitchen, is that you keep your machines running, you keep the VMs running, you can reprovision them with the test command, but with converge, all you're doing is just trying the changes until you get a good test suite. So what I'm doing here is I'm going to get a failure. It should fail when it tries to compile Puppet and says, hey, this doc root should be there. Let's go back and see how far the other guy's done. Alright, so it's installing Busser right now, and it's going to install Puppet next. Again, this might take some time. Alright, so we're moving on. Alright, so right here, this is our Ubuntu test, and it's saying, look, you must pass doc root to Apache vhost. So we know right there that's our problem. Now we could let the CentOS finish, but we're going to end up at the same error. So that's the idea, is you would get an error like that and you would just come back and try to fix it. And that's just in the provisioning step. If we let it get further to do the server spec test and that failed, we'd fix up our spec file and run this again. But let's just do this simple example. So we're going to come in here and we're going to give it a doc root. And then now when we when Puppet compiles this Puppet apply, it will actually succeed, and then it'll be much happier. So we do kitchen converge again, and it knows that I've changed something. So it's going to start where it left off. It'll be a little quicker. And now our CentOS on the first test is almost there. It's just installing Puppet. Once it installs Puppet, it'll be able to run the Puppet apply. It has to install Chef, of course. Alright, so we're ready to run our Puppet right here. Here's the compiling the catalog. This time it should succeed because I've included the doc root, at which point it will then go and configure Apache, like we're expecting. And now it's installing Apache and doing all of the things that the Apache module should do. So it's done with its convergence of that OS. That's done. Now we're going to move on to CentOS. And on this side, we're almost done with our CentOS. Yeah, we're onto our CentOS box on this end. It's doing the same thing, so it's already managed to install Puppet. Everything's up and running and we're great. So now let's go to the test directory. Test integration default. Server spec. And in here, what we've done is we've done very similar to our NTP, but now we've also decided to check if the port 8080 is listening. Now, we made our vhost be 8080, so this will succeed. But let's say, for instance, we got it wrong and it was 8088. We could then do kitchen to verify, and all this will do is run the. We have to go back to the kitchen directory. Kitchen verify. So this will assume that the machines are running, and then we're going to do the tests against them. So it's just going to call Busser and say, Busser, what tests do you need to run? It's going to say, okay, I'm going to run the tests. It's already done the Ubuntu side and it's moving on. Okay, so what it said here is that we had a problem. The problem was that 8088 wasn't listening. And we had the same problem over here, was that 8088 wasn't listening. That's because it's the wrong port. So let's fix that. Let's change it back to what it was. We told it to be 8080. And we do the same thing. We go kitchen, and then we do verify. And this will only do the testing part. So we're assuming the machines are provisioned properly. So if the machines didn't provision properly, we keep iterating through that kitchen converge cycle. But once we have that done, all we have to do is edit our tests and keep going kitchen verify, kitchen verify, kitchen verify, until we end up with what we're hoping to get. In this case, we got 3 tests, no failures. And for the other OS, 3 tests, no failures. And over here on this side, these guys are all done now, so now we'll do the same thing on this side. Kitchen, verify. This is our NTP boxes, which should either be running NTP or NTPD, depending on if they're Ubuntu or CentOS. And again, all it's going to do is bring up the box and verify that NTP is running. So these guys are all done. We're done with the harder test. We're just going to verify that NTP is good on this side. Alright, so now we're getting to the compilation of NTP, and now it's going to run the server spec tests, and it's going to tell us whether or not everything worked, and it did. So there we had 2 tests this time, 0 failures. Then it'll go through and do the same thing for CentOS. And as you can see, these things take quite a long time to run, and you usually don't want to sit there and watch them, so you really need to automate this with some other tool, and that's what Jenkins is for, which we'll look at in the next section. In this video, we're going to be looking at how to use Jenkins to automate the testing that we did in the previous sections. And specifically, I'm going to be concentrating on how to do this for Test Kitchen, but the steps will be basically the same if you were doing it with Beaker or even just plain old server spec. You would be able to use this method. So the first thing to do is to download Jenkins and install it. It's actually included in most OSs these days. It's included in to turn on security and then have it either use the Unix users or make its own users up, or something like that. And once that's up, the next thing you want to do is then install some plugins. So you got to come down to Manage Plugins. And you want to install a Git plugin, or if you're using GitHub or GitLab or any of those, you can use the ones that are specific to that, but I'll show you how to do it with just plain old Git. So if you install the Git plugin, it will install the Git client plugin by default. I also included the Git server plugin just for fun, but really all you need is the Git plugin and the Git client plugin. So once those are installed, you would come and you would make a new project. And I've made a new project called Puppet Module. And this is my project. And in my project, I've just told it that I wish to run Test Kitchen. That's just the description. And what I want to do is I want to say that this is in Git. And then I've specified where to find the Git repository. So srv git testkitchen.git. And if we go back to our code repository, which we made in the last section, first thing we want to do is make a git ignore file. So if I look at my .git ignore, you'll see that I'm going to ignore the modules directory, the temp directory, and the kitchen directory. And then I just do git add .git ignore. You'll see I actually already did this, so I don't have to do anything. And the other thing that I want to do is make this Git repository available somewhere else on the system that Jenkins can get it. At the moment, it's in my home directory. So what I did was I made a Git directory in the /srv mount, and I made it available to the user Jenkins. And if I just do git remote -v, you'll see that I've included a remote for myself, called it SRV, and then told it to push this module up there. So if I made any kind of change, like I made it a README, so if I made a README like that and then I added it, I can then, let's move that up so you can see it. I can then push that to the SRV, which is that other repo, and into the master branch. And you see that's been pushed into that master branch now. That's how this repo is available to the Jenkins user. So if I come in and do a sudo to -i-u -jenkins, I think the Jenkins user won't allow me to do this. Pretty sure, actually. Yeah. So I'd have to actually tell it to run bash prompt, run bash as my command instead. So I'll just tell it to run bash. So I'm now the Jenkins user, and if I went to the SRV Git repository, I'd see that the testkitchen.git is in here now, and I can access all those files. So if I went to temp and went git clone srv git testkitchen.git, I already have one here. I'll just remove it. Oops, I'm not allowed. Someone else already owned it. Alright, we'll just do it as another name. We'll call it test. Okay. So you can see that that README that we just made is available there. So this is all my Git repo has in it. It has my gem file. Gem file says that I want to install Puppet, Librarian Puppet, Test Kitchen, Kitchen Puppet, so that's the plugin for Kitchen, and Kitchen Vagrant, just because I'm using Vagrant as my backend. My Puppet file, the example we did earlier is with Apache, so it includes Apache, and then if we look at our manifests, all we're going to do is create this Apache class and one vhost. And then the tests, that's the interesting part. If we look at that, again, we're just going to make sure that the Apache 2 or the HTTP package is installed. The service is running. I actually want to include the package here, so we should have done that. And then I just want to make sure that the port's listening. So that's all this repo has in it, other than the kitchen YAML file, which is the how do I install these machines. So if we go back to Jenkins, we'll see this is what I was talking about, how we defined how to find this repository. We told it which branch we want to work with, and you can specify how you want this build to be triggered. Right now I'm going to be doing it just manually, but ideally eventually what you want to do is have your git commit hooks do this build for you. So you could have a pre-receive or a post-receive, but most likely a pre-receive hook on your git repo that will go using some token that you made up here and go to the Jenkins server and try a build. And if the build succeeds, then allow the commit to proceed. If not, fail the commit. And here's the actual build. And like I said, it's very simple. Because we're using bundle will install anything that it installs into the ~bin directory. So we just have to make sure that we include that directory in our path, export our path, do a bundle install to install everything that's in our gem file, and then just do a kitchen test. And that's it. So I didn't actually make any changes to that project, but that's the project. And then if you wanted to make a build, all you would do is just come down and say build. And we'll see that there's a new build scheduled, and you can come down and you can look at the console output, and you'll see what it'll do. This is what we told it to do. It's doing the bundle install. It's installing all of these things, the test kitchen, kitchen puppet. It should have installed librarian as well. It's installed puppet. Here's librarian puppet. There's puppet. Alright, so it installed everything, and now it's running kitchen test. So it's already got kitchen, and now the import the machine. So it's importing the base Ubuntu image, and then once that machine comes up, it'll install Puppet on there, and then it will run our Puppet apply just like we did last time. But again, we don't have to watch any of this. This can all be automated in the background. Jenkins can just go and do its thing, and if it succeeds, what we get at the end of this is a nice blue output bubble. Now you see I did a couple tests up here that failed, but this one over here was a success. So if I look at this one, this is one that I did previously and it was a success. And what happened was, if we come down, what it did was, once it installed Puppet, this is it installing Puppet still. So right here is where it did the Puppet apply. So here's our Puppet apply, and then it did my manifest that we had there, which was the Apache. And then once it actually compiled it, it started doing the run, which was to install HTTPD, to set up the Apache module as we expected, and to create that vhost. And once that was done, then it went one step further and it installed Busser and started going through the test suite. So once it had Busser installed, it could then do the server spec tests. So then it would say, okay, I'm going to run the server spec tests. And those tests that we did earlier. So here's the actual server spec type running, and it's going to say, okay, I'm checking for Apache 2, it should be installed. It's checking for the service Apache 2, it should be running, and that succeeded. And then port 8080 should be listening, and that succeeded as well. So we had 3 examples, 0 failures, and this was a success. So this is a success. And then we did the exact same thing for CentOS. So again, it just did a service of HTTP, said it should be running, a port 8080, and said it should be listening. And there's those 2 examples, 0 failures. So the build for both hosts was a success, and the whole build is a success. And the idea of this is that we could have Jenkins doing this continually for us without us sitting there and watching the whole time. It's just whenever we push to our Git repo, this Jenkins job goes off on its own. And you can see that this one here, the one that we just started, is still running in the background even though we were looking at things, and it's finished the Ubuntu test. So you can see here it's done the check for Apache 2 is installed, yes. Apache 2 is running, it said yes, and port 8080 is listening. We had 3 examples and 0 failures, and it moved right on to doing the CentOS one, and it's still in the middle of doing that one, but I don't have to watch it. If you were doing this with Beaker, it'd be very similar. It would just be that the setup steps would be different. But as you can see, this greatly reduces the amount of time that you spend doing the testing. You just let the automation take care of it. And that's about it for Jenkins. In this video, we're going to be talking about APIs, and there's 2 APIs for Puppet that are interesting. There is the Puppet API, and then there's the Puppet CA API. So the Puppet API is on version 3 at the moment, and the Puppet CA API is a new API that's for Puppet 4, and that's on version 1. There's also the Puppet DB API, which is actually on version 4 at the moment. And the documentation for these will tell you what all of the different endpoints are and how to use them. But I'll just show you some really quick examples on how you can use these to diagnose problems that you might have. So using curl is the usual way to talk to these things. You can also just do netcat to make sure that the machine's listening. So you can do netcat-v and then say, I want to connect to my Puppet machine on port 8140. And it'll tell you whether or not you managed to get a connection. Now, if you want to get your CA certificate, you can go to the Puppet-CA endpoint. Again, this is version 1. And then you can say that you want to get the certificate for the CA. And right now we're going to say that we're going to do an insecure connection, so we're not going to verify the SSL configuration of this because we don't know what the CA certificate is, presumably. So if we do get ca.sh, we'll get back the certificate. So you can see that this is the certificate from the CA. And we can also get the CRL. So here's how you could get the CRL. Again, the Puppet CA endpoint. You can go certificate revocation list. This CA here has to be CA. That's really the only option that will work, unless you make some changes to your Puppet CA machine. But if you ran this, you would get the CRL. And that's a fully formatted CRL. So if we went and redirected this to temp CRL, we could then use OpenSSL's CRL command with text output, no out, and we'll pipe it to less, and you'll see less. We'll see that this is a certificate revocation list, and that it has 2 certificates in the revocation list with serial numbers 4 and 9. So we can also get our certificate. So our host name here is puppetdb.example.com. So if we look at this get cert, now I'm actually going to do some verification. So I'm going to have, because I'm going to be connecting to a verified API. So now I have to say, this is where to find the CA. This is where to find my certificate. This is where to find my private key. So now when I'm connecting to this Puppet machine now, I'm going to be connecting with this certificate and this key. So I'm going to be authenticated basically. And I'm going to connect to the CA on V1 and I'm going to get my certificate. Instead of the CA certificate, I'm going to get mine this time. So let's see what happens. If we get that, the theory is that if we do a diff on this one, and the one in set Puppet Labs, Puppet SSL certs, puppetdb.example.com, those should be the same, which they are. And if they weren't the same, that would be a problem, and that would be something you'd want to look into. The other thing you can do is you can actually talk to the Puppet server and grab your catalog. So get it to compile a catalog for your machine. So again, with the cert and the key and the CA cert, these options are all the same. The difference down here is that we're going to accept a PSON. And PSON is just Puppet's version of JSON. Puppet uses its own version of JSON because it wants to use ASCII encoding rather than UTF-8. That's really the only difference. So what we're going to get back is essentially a JSON file. So we're going to connect to Puppet instead of Puppet CA. We're going to use the version 3 of the API. We're going to ask for the catalog, and we're going to ask for the catalog for this machine in the production environment. So if we do get catalog, we're going to get back a JSON or a PSON. And of course, PSON or JSONs are kind of hard to read. So usually what you would do is pipe this to JQ, which is the JSON formatter. And now you can see that this is a little easier to read. And this is the catalog for this machine. So this contains all of the resources, all of the tags up here. So the tags, the resources, and at the end it should say which classes are in it. Yeah. So these are the classes in this catalog as well. It's a very small catalog, but it's really just for an example. So that's how you can connect to the CA. Now if you want to connect to PuppetDB, we're on PuppetDB right now, but let's say we wanted to get the nodes off these machines. So if we go get nodes, this is going to look very similar. We're going to be authenticating, so this will look the same. But now we want to accept a JSON file, and we want to connect to port 8081 via PDB, and we're going to do a version 4 query of the nodes endpoint. So if we go get nodes, you can see that this returns a list of nodes in a JSON, so we can pipe that through JQ, and then we'll see that we get the JQ. And let's say we wanted to look at just this one, Burnaby. What you would have to do is make a query. So here's our query. It's the is like. So this is cert name is like or contains Burnaby. So I'm saying give me anyone whose cert name matches Burnaby. And we'll pipe that through JQ, and we'll see that it just returned the information for Burnaby. There's other endpoints. There's resources. There's facts. So if we wanted to just, let's say we want to copy the get node script and say get fact. We can change this endpoint to facts. And now you see that we get all of the facts for all of the machines that we know about. The name of the fact is DMI, and then this is the value. The name of the fact is SE Linux enforced, and the value is true. So you can go through here and you can look up specific facts that you're interested in as well. The other thing you can do is you can talk, if you're having SSL issues with PuppetDB or you think that might be the problem, you can talk to it locally on port 8080. So that's what this one here. So we've, instead of port 8081, we've done port 8080, and we've dropped all of the SSL communication. We've gone down to HTTP, but everything else looks the same. It's a query, v4, and nodes. But because I'm on the machine, I can do this query and not have to worry, and I can pipe that through JQ as well. So talking to these APIs can be really useful when you're having problems or you want to talk at a lower level to PuppetDB or Puppet and figure out what's going on.
In this video, we're going to be talking about SSL certificates and the X509 SSL certificates used by Puppet. And the best tool to work with SSL certificates is OpenSSL. And OpenSSL will come with its own man page, and each of the commands in this standard commands list has its own man page. So like REQ and RSA, you can say man REQ, and you'll get a man page, or man RSA, and you get a man page. You can also use OpenSSL's shell, so you can say help, and it'll list all of the commands that are allowed. You can then say one of the commands with a -h, and it'll tell you all of the options to deal with that particular subcommand. The ones that will come up quite often when you're working with Puppet are going to be the X509 man page, X509-H, and the REQ man page. Again, I'm doing it wrong. And the X509, the REQ, the verify, and the CRL are pretty much the ones that come up the most. And a lot of these options, a lot of these different subcommands share options, so once you get good at one of them, you can usually do the rest of them. But let's look at verify, because that's something that confuses people. You can do a verify on a certificate if you have the CA available. So I'm in the SSL directory, and if I look in the certs directory, there's a CA there. So I can verify this puppet.example.com certificate by going OpenSSL verify CA file is certs ca.pem, and then the thing that I want to verify is certs puppet.example.com, and it'll just tell me, yes, that's a good certificate. But let's look at what it looks like when you have a bad certificate. So if you do Puppet certificate, and we'll just make a bad cert. The location is local. And then we'll sign it. And now when we look at CA in the sign directory, we'll see that bad cert is there now. And we can verify that certificate, so we'll just say OpenSSL
verify. CA file is certs CA pen, and we're going to do CA signed bad cert. And it'll say everything's good. But now let's copy CA signed bad cert into temp, and let's clean. So this is going to revoke the certificate. So bad cert has now been revoked. So now the thing is, if we do the same command that we did before, which was to verify it, but now we're going to tell it to look in temp, which is where the copy is, we'll see that it still verifies correctly, and that's because the certificate revocation list has not been looked at. And the certificate revocation list is right here. It's also in the CA location. So what we can do is we can say OpenSSL CRL, and we'll look at the options for CRL, and what we basically have to do is just tell it where to find the CRL. So we're going to say in is CA CRL.pem. We're going to say no output so that it doesn't output the file again to us, and then we want to look at the text representation of that CRL, and we'll just pipe it through less. And we can see that these are the certificates that have been revoked, and they're in the list here. So we've got 4, 8, 9, and C. And if we go and look, this serial number here, the serial number matches will match the certificate that we just destroyed. So how do you get the serial number and other information out of your certificate? You go up in SSL X509, and then in will be temp bad cert, and the X509 bad cert.example.com.pem, no out. We'll do the text representation of it, and we'll pipe that to less. And you'll see this is all the information out of the certificate. Now the serial number of this is 0xc or 12. That serial number will match one of the serial numbers in the CRL list. Now to get the verify command to actually work, what we want to do is we're going to cat the CA, the CRT, that's the CA certificate, and the CA CRL, and we're going to output those into a crl.pem file. Now we're going to do OpenSSL verify CA file is certs CA, and now we're going to do a verbose, and we're going to also specify where to find the CRL. So now the CRL is embedded in the same file, so we want to just say CRL check as well, and we're going to look at badcert.example.com. And now we can see that the bad cert, so we tried to do the verify and we didn't give it the path to the one that contained the CRL. So let's do that again. Alright, so now it's going to say that the certificate has been revoked. Whereas if we didn't do the CRL check, even if we had the CRL available, you can see that it thinks that it's okay. So really the difference between doing the revocation check and not makes you think that maybe the certificate's good, but you need to always verify with the CRL to see if the certificate is actually good. Another thing that's useful is to look at the fingerprints of the certificates, and you can do that with the X509 command. So you can just say OpenSSL X509 in that same bad cert, just for fun. And we're going to say fingerprint and no out. And that's going to print the fingerprint. Now that's going to be the SHA-1. Now if you want the SHA-256, you just have to say, I'd like the SHA-256. And you can also ask for the MD5. The SHA-1 and the SHA-256 are going to be the most common ones you'll see. Now, Puppet also can give you this information. So you can say Puppet, cert, fingerprint, and then it has to be one of the ones that wasn't revoked yet. So we can do puppet.example.com. And you can see that's the same information than if I had gone OpenSSL x509-in, and then certs, puppet.example.com, and fingerprint, and SHA-256. Oh, and no out. So that's with that, and then there's this, and these two numbers should match up. You can see that they do. All I really wanted to say about certificates, basically get comfortable with the OpenSSL shell. Useful to do those types of commands like x509-in, certs, and then puppet.example.com, and fingerprint, like that, and no out, and it'll tell you. And the nice thing is that you can work all your commands out like this. The other thing that's useful sometimes is if something gets screwed up in your CA. So in your CA, you'll see you have this inventory file. And this inventory.txt basically just says which certificates were assigned. And you can see that right now it says that bad cert is there, but actually bad cert isn't here anymore because we destroyed it. So what you can do is you can say puppet cert re-inventory, and what it'll do is it'll recreate this inventory file based on what's actually out there right now. So if we look, we'll see that bad cert is now no longer in the inventory. And that's something you probably want to run out of cron every once in a while, or when you do a mass deletion, you come through and delete that. And that's all I really wanted to say about certificates.
In this video, we're going to be talking about metaparameters and ordering. Now, metaparameters are parameters that you use to enforce order. There's four main types of metaparameters. There's before, require, notify, and subscribe. And before, it's pretty obvious. It just means whatever you want has to come before whatever you specify. So if I say A before B, I mean that A has to be applied before I can do B. And before and require are related in that A before B is the same as saying B requires A. So they're basically equivalent. So you can put the A before B, you would put that in the A resource. And in the second instance, you would put it in the B resource and say that B requires A. And notify and subscribe are also sort of similar to each other in that notify, basically, it really only applies to a service, but you want to say that there's a service that you wish to notify, and notify will cause the service to reload itself. It'll either restart or reload depending on the service. And subscribe is the thing you would put in the service itself. So in the service you would subscribe to something else to have it sort of trigger if there was a change. Another thing that's really important to note is that there is a system of auto requires in play that kind of obfuscate some of the inner workings of metaparameters and make it sometimes a little bit harder to figure out what's going on. But by default, things aren't automatically done for you. So let's say we have this file resource and we want to make it in the directory tempd. And if we look at tempd, there's nothing there. So if I try to apply this, because I don't have any holder for this, nothing's going to happen. So what we need is a better example. So let's look at this. What if we say tempd is a directory, and I'm going to use a chaining arrow here, which is another type of ordering. You can say that this thing up here has to happen before this thing. So that's not going to work, right? Because we're going to be trying to create the file before we create the directory. it's going to fail, right? Because you can't do it. Now, what if we just take that out? If we take that out, now the auto require will basically say that I know that this thing, this E requires the directory D, and I've got the directory D right here. So I'll do the directory first, and then I'll do the file. So I haven't specified any order here at all, but because of the auto require mechanism, Puppet will do the right thing. Right, so now it's made the directory for us and everyone's happy. But it did that automatically, and actually it's sort of a bad thing because you don't, when you're first learning how to do this, you don't realize that that took place. And it's actually better to just specify it yourself. Let's do this the right way. So this would be the right way, would be to come down and say, this temp DE requires that the temp D be there first. So I'm saying I require this be applied first. So if I remove that directory and I do the same application that I did before, now it's exactly the same, they both succeed, and you can check for a success by looking at the return value. Now 0 is a success, 2 is a success with changes, and 6 is a failure. So if we did this apply right here, everything's great, but we actually specified the order here, and that's actually a better way of doing it than the one where we're just doing the auto require. It's sort of cheating using the auto require. But what does this mean in the real world? So let's look at a better example. This is a bit bigger example, but let's say we want to have Nginx running. So that means we need the package at Nginx. We'll put that in there. We'll make a configuration file for Nginx. So we'll create a file resource for that. And I'm using a here doc. This is just stuffing everything that's in here into this variable, and then I'm saying that variable is the contents of this file. And I'm also going to say that I need the conf.d directory. So I need this, I need this. Now, these two, this file will require this using the auto require mechanism, but the set nginx file, that directory won't exist until the package is installed, and the service can't be started until the package is installed. So depending on how Puppet decides to start these things up or apply the resources, this manifest probably won't apply. And just to make sure, I will. I don't have Nginx installed. Double check. Okay, everything's out of there. So now if I try to apply this, what's going to happen is it'll either try to start the service first. Yeah, so it's trying to start the service without having the package available. Then it created the package. Now, because it created the package, it was able to create the files, so that worked out okay. But if it had tried to create the files first before the package, then it would have failed. And we can see that Nginx isn't listening now. It's not running because the service didn't work. And if we do a Puppet apply meta 5 again, because the package is there now, the service will be able to start and the files are already there, so we'll get a clean run. And this is what people that are first starting out with Puppet will say, oh, you know, it works the third time, the fourth time, and it's really because you haven't specified the order to make things work properly. So let's say, and we can run this again, because the state has now become stable, we won't see any changes at all this time. It'll just run and say, I'm done, I'm done. And if we look with an LSOF, we'll see that Nginx is running on port 80 and it's using the configuration file we made. So let's try removing that. So let's get rid of the package. And we'll get rid of the directory. And now let's make another example. Now in this example, we're going to do a lot of ordering. So we're going to say that the service requires the package, and this configuration file requires both the package and the other directory down below. And this one just requires the package. Now, I'm being very explicit actually, because right here I only need to really require this file, because if this file right here is already on the system, then that means that the package is already here. And that's just, this is basically a redundant thing, but it's good to see how you do two. So this is an array of requirements. So I'm saying I need the package resource and the file resource. So now we don't have Nginx installed, we don't have the directory installed, but if we do a puppet apply meta 6, it's going to install Nginx first, then try and start the service, then do the files. Now if the files change, it's going to notify the service and tell it to restart. So it actually decided that instead of doing that, it would just do the service last, which is fair game. So if I say, let's just double check first. We have a clean run, right? Everything's great. We run again, should be no changes because the first run was completely successful, so there's nothing to be done. Again, clean, and Nginx is running. So that's what meta parameters do for you, is you basically specify the order that you want things to happen in. And if you do it right, your first run will always be good, and you won't have to do this thing that people say where you run it 3 times and then it works. If you're doing that, you're doing it wrong, and you really need to be specifying the order of things to make it work properly. The only time that you might need to run it more than once is if you're using something like Windows that needs to reboot in the middle of a run, but otherwise you should be able to do everything in one run. In this video, we're going to be looking at how to use pry to inspect the Puppet server. And Puppet server is the new way of running a Puppet master, and it runs Puppet through a JRuby instance within Java, which makes things a little bit interesting, but not too bad. One of the main things is that you get this Puppet server command, and you can do things like Puppet server gem list, and this runs the gem of the JRuby within the Java process. So it takes a while. That's one of the things about Puppet server is there's a long startup time, but once it's running, things are generally a lot quicker. And to install pry or use it within Puppet server, we have to do Puppet server gem install pry. So we can see that I've already done that, and pry is now installed for the Puppet server. The other thing that Puppet server gives us is, if you do Puppet server help, there's a few commands you can use. You can have an interactive Ruby session in Puppet server. And one of the other ones you can do is you can run Puppet server in the foreground. So what I've done is do that over here. I've just said Puppet server foreground, and then this will take quite a while, but when it's finally ready, you'll see this message about ready to handle requests. So the next thing to get so that we can use pry is to just make a function that calls pry. So what I did was I made a module. So if we look in our modules, pry, lib, puppet, parser, functions, and I called it pry. And all I did was make a new function. I called it pry. I said require the pry library and then start up pry by going binding.pry. And if you've ever used pry before, you'll know that this is really all you need to do to get pry up and running. Now, what we have to do then is come into our manifests, to our site pp, and just attach a pry function call right here. So our entire catalog is just going to be 2 notifies and then a call to pry. So if we start a Puppet agent run here, we'll just do that. And what we'll see is it'll go loading facts, and then it'll appear to just halt. And what's happened is over on the Puppet server in the foreground, we're now in a pry loop, and we can inspect this running Puppet process that has just compiled the catalog for that node. So I can say Puppet and environment and see the running environment, I can look at the catalog. The catalog is available. It's just called catalog. It is of type catalog. We can look at the catalog resources. We can the methods of those. So these are all the various methods that are available there. And we can actually alter this, but let's do a clean run right now. So let's just exit out of this. Now, once we exit out of this pry loop, the rest of the catalog will continue. It'll finish and send it over to the agent, and we'll see the normal run. So it does a notify, a first notify, and then a second notify. Let's do that again, but let's prove that we can actually change something. So we'll wait. We'll get into the pry loop again. And now let's look at that last catalog resources. It's the second notify, so let's modify it. So let's do catalog resources, -1. We're going to set the parameters. And the param that we want to set is the message. And we want to make the value equal to try is lots of fun. Something like that. Alright, so that's changed the set parameters, not set parameter. We're going to change the value, but I'm going to type it correctly this time. Param equals message. So now we've changed the message of that last catalog. So if we look at the last resource in the catalog, you can see that we've changed it to pry is more fun than my typing. And now when we exit, this will send the catalog over to the other end, but we'll see that the message has now been changed because I was able to change it in the catalog before it was sent back to the agent. So doing this, you can inspect the running catalog of the Puppet server, and it's particularly useful if you have some sort of problem with your function, your custom function, or I've used it often to inspect the values that Hiera is looking up. But using pry with Puppet server is a very useful way of getting in and seeing what the Puppet server is actually doing.
In this video, we're going to be talking about Puppet best practices, and one of the main things that gets referred to as a best practice in Puppet is to adhere to the style guide. And a lot of the style guide centers around syntax and formatting. And many of the things that are covered by syntax and formatting can be done with the Puppet lint tool. So you can correct most of the problems you have with that with the Puppet lint tool, but there are a lot of other things in here that are useful to talk about. Specifically about classes, to make sure that you try to avoid class inheritance, when to use the chaining arrows and when to use before and after and meta parameters. Keep your classes in separate files whenever possible. There's a lot of useful things in this style guide, and I recommend just going through it. But one of the things that you can do that'll help you out is running tools like Puppet Parser Validate and Puppet Lint. But doing them often means that it's actually much easier to just define bash functions for yourself to do this. So these are a couple of the ones I have. I have a function here that tells me whether or not the command that I give it, if the syntax was okay or if it wasn't. It prints it out in color if my terminal supports it. And then I have a function here that validates ERB files. So that's why it's validate ERB. I validate YAML files. I run the Puppet Parser Validate, or I just have an alias for Puppet Lint. And the idea is that, let's say I had these files here that were bad, I could do Puppet Parser Validate that, and this would fail, And if we look at ppv.pp, we can see that this starts here and ends here, and there's no ending for this. So I made a better one. So let's ppv.pp.good. You can see I've corrected the one problem, but then I still have another one where there's still no title for this. So if I do a ppv on the ppv.pp.better, the syntax check passed. So everything's great there. The only thing to point out is that this file still has a problem. You really can't have two owners for a file, and the Puppet parser validate's not smart enough to know that that's a problem. So take it with a grain of salt. It's useful, it's helpful, but it's not the magic that you need. You still have to be a little smart about this. Another thing that I like doing is linting. So if I just do PL, that's my Puppet lint. So I'll tell it to find the lint in it, and it'll tell me whether or not there's issues with this. So if we look at that file, we can see that the arrows weren't aligned. It told me all about the arrows being aligned. It told me that this line is way too long, and it also tells me that the ensure, I put the ensure way down here, but the style guide says that ensure should be the first thing. And that's a really useful thing, actually, because if this ensure was something like ensure absent, I could go through reading all the conditions getting up to this point without realizing that the entire thing doesn't matter, because the ensure is just absent. So this whole resource wouldn't exist in the catalog. It would just be, I don't need it. So that's a useful thing. Let's see, I have a YAML file and I have an ERB file, so I can just quickly go v ERB or verb, and it can tell me, well, there's a problem with your ERB file. I can say, okay, well, I screwed up there, didn't I? I was supposed to put this in quotes, and if I fix up my errors, like this is just a very simple ERB file, but if I went ERB on this one, it would tell me, yeah, the syntax is good on that one. If we look at my YAML file, you say, oh, this is a pretty good YAML file. Everything looks good there, right? But actually, it's going to tell me, you know what, I was expecting a colon here on line 6, but I didn't get it. So I can see vi YAML. I can go +6 to go to the 6th line, and here's the line. And look, I've got an equals where I should have a colon. So it should be more like this. Actually, those should be like that. But now if I do vyaml, YAML.YAML, hey, the syntax is good. The reason we do this with the Ruby YAML library is because that's the one that Puppet's going to use. So you might be able to do this with a Python trick as well, but using the Ruby one ensures that any of the errors that are found are the same errors that Puppet will report. A couple of other things that are a little more esoteric as far as best practices. When you're making your own custom facts, you should make sure that your custom facts calculate quickly. You basically, if there's anything that's going to take a long time to run, if you had something that was going to do like a yum check update or something like that, that's a very long running operation. It could take quite a while. So what you would do usually is make a script that outputs a YAML file or a text file and sticks that in the factor directory. Etsy factor facts.d. And by doing it that way, you basically reduce the time that it takes to run factor, because when you run factor on a system, it should be relatively quick. If you run factor, it should be running relatively quick, especially with modern versions of factor. This is a fairly recent version of Factor, which is written in C now, so it's much quicker. So basically, if you're writing your own custom facts, they should calculate as fast as possible. The other thing is to use the forge wherever possible. So go to the forge. If you're looking to do NTP, for instance, go there, search for whatever you're looking to work on, and use the module. If the module that you find on there doesn't do exactly what you think it should, or it doesn't work the way you want, fork it. Go to GitHub, fork the repo, and submit a PR. The more the people that do that, the better things get. If you do look on here, the number of downloads is really important because it means that there's a lot of people looking at the code. So if I was going to choose between these two, I'd probably go with this one, even though we like Garrett's version 2, but this is the Puppet Labs one. This is also supported, this one, so this is run by Puppet Labs as well. The other thing to do is, even if the module on the forge that doesn't do exactly what you want, start with one and copy it. Some of these ones that are downloaded quite a bit, this code has gone through a lot of code reviews, so you should look at this for some best practices as well. And the last thing that I can't stress enough is the KISS principle. And the KISS principle is something that came out of the Navy in the 60s, and it's basically to keep it as simple as possible. So when you're designing your Puppet infrastructure, or when you're designing your modules, if there's an elegant solution but it's complex, go with the simple one, even if it's ugly, because complex things generally break, and simple things, if they do break, they're much easier to fix. This is really the biggest principle you can get with your Puppet infrastructure, is just keep it as simple as possible. Try to keep as few modules as you can, and wherever you can, actually group your modules together. So a lot of places will make a base module where they go through their infrastructure and they find all the commonalities, all the things that are the same on the machines, and they make a base module out of that. And that way they don't have to repeat that code all over the place. A lot of places will use a base module path as well and include a set of known good modules that they'll use. Standard lib is one that people put in their base module path fairly regularly. And the last thing I can't stress enough is to avoid environment sprawl. And that is where you have more environments than you need. Try and keep the number of total environments on your Puppet server quite low. Many of the Puppet tools break down when you have hundreds of environments. If you can keep it less than 100, things work much better. And that's all I wanted to say about best practices.